Welcome for the morning session. We are delighted to have Michel Bitbol here from Paris. Very sad that he's not actually here physically in person, but delighted to have him here to talk about two dimensions of interdependence, relational quantum mechanics and cubist relativity. Thank you.
Thank you very much. So in this talk, I wish to compare two interpretations of quantum mechanics from the standpoint of their connections to the Madhyamaka school of Buddhism. These two interpretations are relational quantum mechanics on the one side and cubism, namely quantum Bayesianism in its simplest acceptation. These two interpretations of quantum mechanics have something in common. It is their emphasis on the relativity of determinations and states, and therefore their affinity to the Buddhist concept of pratitya samutpada, namely interdependence. Yet their approaches of relativity are hugely different, and it is this difference I wish to scrutinize. I will then give some philosophical and Madhyamaka reasons to prefer cubist relativity over relational relativity. Quantum mechanics has inherited from the old natural philosophy the Platonician dream or illusion of Western science as a whole, namely the dream of disclosing the intrinsic nature of things by identifying them to mathematical idealities. Yet, quantum mechanics also gives us strong reasons to dispel this Platonician dream, especially by changing the meaning physicists usually ascribe to the mathematical symbols of their theories. Indeed, interpreting mathematical symbols of quantum mechanics, such as state vectors in a Hilbert space, as a complete or incomplete description of the deepest nature of reality out there is the most important generator of paradoxes and conceptual difficulties in the interpretation of this theory. Is it then conceivable to clarify the meaning and scope of quantum physics by appealing to philosophies which do not belong to the Western cultural inheritance, such as the philosophy of the Madhyamaka school of Buddhism? A philosophy that is as far as possible from the extreme realism of idealities typical of the Platonician heritage of Western physics. This is made plausible by the well-known fact that most of the so-called paradoxes of quantum physics are dissolved straight away as soon as one accepts that the microentities are empty of intrinsic being and empty of intrinsic determinations. A good example is the celebrated paradox of the combination of a wave nature and a particle nature in one and the same entity. These two so-called natures are incompatible, since one of them is infinitely extended in space, while the other one is narrowly located. These two natures can at most be stacked on top of each other by way of the pilot wave formalism of De Broglie and Bohm. But the former paradox and incompatibility of wave and particle natures immediately dissolves without any need to find a solution to it as soon as one renounces the idea that microscopic entities are endowed with intrinsic absolute natures. Niels Bohr inaugurated this kind of dissolution of quantum paradoxes by discarding the concept of intrinsic absolute natures. According to him, according to Bohr, there are no waves and no particles at all in the independent world. There are only wave-like phenomena and particle-like phenomena. And these two phenomena are complementary aspects of the microscopic domain relative to two different kinds of experimental contexts. Relativization is an ongoing process and a rising tendency in the interpretation of quantum mechanics. It concerns more and more features of the so-called physical world. Relativization first concerned microscopic properties, then microscopic entities, and more recently, macroscopic observable experimental facts. In this slide, we start with microscopic properties. The idea of relativizing the properties of microscopic entities popped out at the very origin of quantum mechanics in 1925, when Heisenberg first formulated an early form of this theory called matrix mechanics. Let's read the following crucial sentence of his original paper. Quantum theory, he said, may be seriously criticized on the ground that it contains relationships between quantities that are unobservable in principle, such as position and period of revolution of the electron. Our program is to establish a theoretical quantum mechanics analogous to classical mechanics, but in which only relations between observable quantities occur. End of quote. Now, what does Heisenberg tell us here? In classical mechanics, one describes relations between continuous quantities such as position, velocity, or periods of revolution of material bodies. These quantities are supposed to be intrinsic properties of bodies, and they can, in principle, be continuously monitored by an observer. But in the quantum domain, continuous monitoring of these quantities by an observer becomes impossible. One usually says that observing them is disturbing. Moreover, tacitly assuming that these quantities intrinsically exist even when unobserved, as the old theory of quanta did, may yield consequences that are contrary to experimental facts. So what Heisenberg proposed was to establish law-like relations between these continuous observable quantities, namely between quantities that are explicitly recognized as relative to an act of observation. Notice at this point that the relativity of quantities to an act of observation manifests as a sensitivity of their values to the order of their observation. And mathematically, the relativity of quantities to an act of observation is expressed as the non-commutativity of these quantities. Now, this relation of non-commutativity, which is written just below Heisenberg's portrait, was not just acknowledged by Heisenberg. It was posited by him as a crucial postulate of the new quantum mechanics. Therefore, we can say that Heisenberg raised relativity to an act of observation to the rank of the most basic principle of his quantum theory. Bohr later made sense of the relativity of quantities to an act of observation by pointing out that in any observed phenomenon, one cannot even disentangle the influence of observation from the putative properties of objects. And he concluded beautifully that, I quote him, an independent reality in the ordinary physical sense can neither be ascribed to the phenomena nor to the agencies of observation, end of quote. So now, beyond properties, even entities are concerned by the universal relativization that is required by the quantum situation. In fact, one should not think that entities somehow exist either intrinsically or relative to observation. One should rather consider that what we have primarily is only discontinuous phenomena, experimental data relative to observation, and that we then inquire into the possibility of or impossibility or of considering these scattered phenomena as manifestations of persistent entities. To start with, what Philippe Goyal told us is that even this is not possible in general in the quantum situation. In general, we cannot make sense of such scattered experimental data relative to observations by considering them as manifestations of permanent entities. But we cannot make sense of them by considering them as manifestations of non-persistent entities either. Persistence and non-persistence are no intrinsic features of intrinsically existing entities. They are just models that we apply to scattered data and that we must combine in various proportions relative to various experimental situations. Then we know that in a pair of correlated particles, certain features of these so-called particles are not only relative to observation, but relative to each other. This is the case, for instance, of the Z component of spin. But beware, there are circumstances in which no other characteristic than this Z component of spin can serve to distinguish one particle from the other particle of the same pair. So, in this case, even the identity of particles is relative to each other. And since, according to Quine, there is no entity without identity, one may consider that in their very existence, qua entities, particles are relative to each other. Finally, in quantum field theory, the number of particles is unobservable in the sense that it is relative to an act of observation. This feature, combined to many others, led some prominent authors to radical conclusions. For instance, Schrödinger, the particles in the naive sense of the old days do not exist. Or Paul Teller, a particle is not a thing that exists or doesn't exist in the absolute. Moreover, the idea of relative existence of particles was beautifully expressed by Bernard d'Espagna and some other authors. He said, particles have the mode of existence of the rainbow, namely a relative mode of existence. Okay, now, quantum relativity doesn't stop at this point, namely it doesn't stop at entities and determinations. Quantum relativity is not restricted to microscopic properties or microscopic entities. It also concerns a feature that looks intangible because it occurs at our mesoscopic scale and because it is the basis of any claim about the world. This feature is nothing less than facts, tangible experimental facts in our labs. Doubts about the intrinsic existence of facts arose from an intricate thought experiment derived from the famous Wigner's-Friend thought experiment. This further thought experiment contradicts quantum predictions under the three following assumptions that you can read on the slide. One of these assumptions, the second one, is the independence of facts with respect to observers' situations. To many physicists, it looks like the absoluteness of facts is the assumption that is harder to get rid of, and they therefore propose to relinquish assumption one. But several interpretations, including cubism, relational quantum mechanics, information theoretic approach, or even the pragmatist approach of Richard Healey, agree that the absoluteness of facts is precisely the assumption to be renounced in this case. In other terms, facts are relative. And as you see, facts are relative is the title of a recent paper by Czeslaw Bruckner. Okay, despite this remarkable agreement about the relativity of facts, a fierce debate recently arose between two of these interpretations, cubism and relational quantum mechanics. Why is it so? I will try to identify the philosophical root of the divergence between two thoroughly relational interpretations of quantum mechanics. Then I will translate this philosophical root in Buddhist terms. Okay, now the philosophical root of the debate. The crucial issue was raised by Sextus Empiricus, a late proponent of ancient skepticism who lived in the Roman Empire. He distinguished two types of relativities: relativity of object to subject and mutual relativity of objects. And I must insist on that, he did not even think of reducing the relativity of object to subject to a special case of the mutual relativity of objects. At any rate, this manifold relativity was the central reason Sextus Empiricus found to suspend judgment as to the own nature of things and to become a skeptic. Much later, in the 18th century, the philosophy of Immanuel Kant aimed at overcoming skepticism rather than promoting it. But since Kant was a heir of Galileo and Newton, he knew he could not do so, namely, he could not overcome skepticism by denying the thoroughly relational nature of physical knowledge. So Kant undertook a thorough inquiry into what Sextus Empiricus called the two senses of relative. In order to show that a relative knowledge can in fact be a reliable knowledge. But in the course of his career, Kant held two very different, almost opposite positions about relations. The first position has been called pre-critical, and the second position has been called critical. The first position was associated to a naturalized epistemology, whereas the second position was associated to a transcendental epistemology, of which, of course, Kant was the main author, the founder. According to the first position, formulated in 1756, all substances are dynamically related by way of reciprocal forces, the famous Newtonian forces, of course. And the relation between the knower and the known, between subject and the object, between the mind and the bodies, is here considered as a special case of the universal meshwork of mutual relations that take place between objects or between bodies. But the second position, whose mature form can be found in the Critique of Pure Reason, published in 1781, is very different. According to it, the object-object sense of relative is itself relative to the subject-object sense. Kant even insisted that the reason why we have to accept that objects are pure webs of relations is that these objects are themselves defined relative to an act of knowing performed by the subject. In the first pre-critical position, relations are all there is in the world. But in the second critical position, even relations are relative. They are relative to an act of cognition. The thesis I will support in this talk is that relational quantum mechanics, the theory supported by Carlo Rovelli, is a pre-critical relationism associated with a naturalized epistemology, and that cubism is rather a critical relationism associated with a transcendental epistemology. Let me now come to the translation of this momentous philosophical difference in more Buddhist terms. Okay, in Madhyamaka Buddhism also, there are two conceptions of emptiness qua lack of own being, and a twofold articulation of relativity. There is a positive characterization of emptiness as dependent arising, as in this sentence by Nagarjuna, namely, the being dependent of beings is called emptiness, end of quote. As for dependent arising, it is construed as a symmetric relation of co-production or mutual determination to be strongly contrasted with an asymmetric productive causality. It is on this point that a strong convergence can be found with the concept of quantum non-separability or entanglement, which is also a symmetric relation of mutual determination and mutual correlation, of course. But there is also a negative characterization of emptiness as rebuttal of any view of the intrinsic nature of the world, including the view that the world is intrinsically made of a relational network of dependently arising items. The first characterization of emptiness has something in common with Kant's pre-critical conception of relations. And the second one is close to Kant's critical conception of relations. Now, let me come to the twofold articulation of relativity, which is very similar to the one of Sextus Empiricus. Firstly, there is an object-object or phenomenon-phenomenon kind of relativity, as stated in several sentences of Madhyamaka authors, especially in this first sentence of Nagarjuna, which is written here. If this exists, that exists, in the same way as when there is the short, there is the long. The example is quite similar to the one of Sextus Empiricus, who spoke of the co-relativity of right and left instead of short and long. And it has been complemented with many other examples, such as the co-relativity of part and whole. Secondly, there is a subject-object or subject-phenomenon articulation of relativity, as stated in several sentences, especially the second sentence of Nagarjuna, which is written on the slide. Knowledge and the object to be known do not exist by their own being. And also, when valid cognizers exist, then there are objects which are objects of comprehension. And when objects which are objects of comprehension exist, then there are valid cognizers. This is from Chandrakirti. If we want to know if Nagarjuna's view of relations is critical or not, or pre-critical, I would say, we have to ask the following questions. First question, is the subject-object relation reducible to a special case of the object-object relation? A positive answer to this question would be tantamount to claiming that the world is made of a real network of relations and would then be similar to Kant's pre-critical view of relations. The second question to be raised is this one. Is there instead a self-dissolution of the relational view of the world by generalized relativity, especially by reference to subject-object relativity? A positive answer to this question would be much closer to Kant's critical view of relations. So let's now examine the two selected interpretations of quantum mechanics. Relational quantum mechanics, which looks like a pre-critical relationism, and then cubism, which looks like a critical relationism. So relational quantum mechanics first. So relational quantum mechanics proposed by Carlo Rovelli in 1996 can easily be appreciated by observing that it is somehow halfway between two more venerable interpretations of quantum mechanics, Bohr's interpretation and Everett's interpretation. To begin with, one must recognize that relational quantum mechanics is much closer to Bohr's than to Everett's interpretation about the status of the state vector. A tool for predicting the probability of unknown facts that we find in a paper by Carlo Rovelli is much closer to Bohr's symbolic scheme permitting only predictions than to Everett's description of a multiverse. But as shown in this table, all the other features of relational quantum mechanics are halfway, in the sense that they combine features from both Bohr's and Everett's interpretations. Let me just emphasize the status of the observer on the fifth line of the table. In Everett's interpretation, the observer is some given physical system. It is itself an object of the theory, yet with some non-conventional properties, such as memory. But in Bohr's interpretation, instead, the observer is radically meta-theoretical. It's not an object of the theory, with its capacities to experience phenomena and to speak ordinary language complemented with concepts of classical physics. Then, in Bohr's interpretation, the observer serves as a condition for the test and the validation of the theory, rather than reducing to an object of the theory. Now, in relational quantum mechanics, the observer can a priori be any physical system correlated with another physical system, so that the two systems get mutual information about each other and generate relative facts. This feature sounds like Everett's naturalization of the observer. But at the end of the day, in the relational interpretation, a true observer is a macroscopic system capable of triggering a decoherence process that yields a stable fact. That is enough to introduce some similarities with Bohr's singling out of the observer with respect to standard physical systems, yet sticking to the framework of a naturalized conception of the observer. Okay, now the problem is that as any naturalized epistemology, relational quantum mechanics faces the famous Munchausen trilemma. Namely, it necessarily falls into one of the three following traps, or even maybe all of them almost at the same time. Namely, dogmatism in the sense of tacitly positing an arbitrary foundation, vicious circularity, or infinite regress. I start with circularity, which manifests in certain definitions of relational quantum mechanics, such as this one. Let me quote. Events or physical facts are realized in interactions between any two physical systems and are relative to these systems. Here, it sounds like physical systems are pre-existent entities that may establish interactions with one another, thereby giving rise to events relative to them. But we also read in the same book of Carlo Rovelli that it is not the things or the systems that can enter into a mutual relation, but it is the relations that give rise to the notion of thing or system. Here, it rather sounds like, conversely, physical systems are byproducts of some non-supervenient relation. So just as the chick and egg paradox, which comes first, the physical systems or the relationships? Then comes infinite regress. The question is, relative to what does a certain relation between two systems hold? The natural answer in this naturalized framework is it holds relative to a third system, as you read in the quoted sentence. But where does this stop? At which point? Third, fourth, fifth system? Okay, but then comes dogmatism, namely the tendency to posit an arbitrary foundation without recognizing it. Here, this unseen foundation is a sort of God's standpoint from which an overall net of relations is seen as the true intrinsic nature of the world. This way of seeing things from an unacknowledged vantage point results in a realism of relations, and this realism of relations is seen almost everywhere in the writings of the supporters of relational quantum mechanics, as you can read in some quotations on this slide. The debate between relational quantum mechanics and other interpretations that also accept the notion of relative fact bears precisely on this point. Bas van Fraassen, for instance, insisted on the net of relations itself being relative to an act of observation. And Jacques Pienard, a prominent supporter of Cubism, insisted that to be self-consistent, relational quantum mechanics should by no means absolutize relations. It should rather recognize that its net of relations is itself relative to the observer or the agent in the language of Cubism. Okay. Now, discarding absolutization of relations was also a crucial line of argument of Madhyamaka Buddhism. Interestingly, this was perfectly acknowledged by Carlo Rovelli himself in his remarkable recent book, Helgoland. There, Carlo insisted that according to Nagarjuna, relations also are relative, or that emptiness of own being is empty of own being. One can find remarks of this kind almost everywhere in the work of Nagarjuna and also in the writings of other Madhyamaka authors. Let me quote especially this one by Nagarjuna. For whomever emptiness is a view, that one has accomplished nothing. One should not, to be self-consistent, transform universal relativity into a thesis of the absolute existence of relations. This radical suspension of any view, of any thesis, including the thesis of universal dependent arising that is often associated to it, makes Madhyamaka similar to phenomenology. This similarity between Madhyamaka and phenomenology, between the Madhyamaka suspension of any view and the phenomenological suspension of judgment, or epoche, was recently pointed out by Georges Dreyfus in a paper. And I think Georges Dreyfus is right on this point. By its suspension of judgment, or epoche, phenomenology brings us back to pure, uninterpreted, naked lived experience. But it doesn't elaborate the further thesis of the intrinsic existence of experience, which would be tantamount to uphold dogmatic idealism. In phenomenology, conscious experience is not the name of an entity, but a sign towards the condition of possibility for aiming at any entity whatsoever. Actually, phenomenology is neutral as to what exists and as to what entities are. As Georges Dreyfus writes, I quote him, phenomenology makes no more claims about what consciousness is in reality than about what things really are. This is what I think we should find inspiration in phenomenology if we wish to follow the path started by relational quantum mechanics and yet go beyond it to fully accomplish its relational project. Okay, now how can we dissolve the Munchausen trilemma that I have formulated earlier? Just by positing a conventional or de facto starting point that plays the role of a foundation without being a real foundation. But is it really possible to do better than an interpretation such as relational quantum mechanics, which is committed to a naturalized epistemology? How can one avoid the Munchausen trilemma? I think it's by consciously choosing the first branch of the trilemma, thus transforming the dogmatic foundation into a dynamic, conventional, effective departure point of the inquiry. This is precisely what a neo-Kantian or phenomenology-based transcendental epistemology does. And this is also what the proponents of the Copenhagen interpretation of quantum mechanics did in their way. Hence, for instance, Bohr chose two pre-theoretical or meta-theoretical concepts as conventional departure points. The concept of experimental arrangement described by ordinary language, supplemented with classical concepts. And also the concept of human lived experience. These are two pre-theoretical concepts that are introduced by Bohr. As for Asher Perez, a remarkable later defender of the Copenhagen interpretation, he decided to redefine the theoretical terms such as physical system and quantum state in terms of Bohr-like pre-theoretical or meta-theoretical terms such as preparation and experimental tests. Okay, notice that such conventional meta-theoretical departure point play the role of a primary relatum relative to which both theoretical terms and facts are defined. But the culmination of this epistemological tendency might well be represented by cubism, the interpretation formulated by Chris Fuchs. This is why I now attempt a systematic comparison between relational quantum mechanics and cubism, based respectively on a naturalized and a transcendental epistemology. Okay, there are some points of agreement between these two interpretations of quantum mechanics. No absolute facts, quantum states construed as predictive tools about relative facts are two such points of agreement. But there are also several points on which the two interpretations disagree. In the relational interpretation, the difficult issue of where to locate the boundary between the classical and the quantum domain, or between the experimental device and the physical system, is solved by equating the experimental device and the observer with a physical system. Instead, in Cubism, the same issue of boundaries is solved by pushing the boundary to what I could call its transcendental limits, namely by implicitly restricting the non-quantum or pre-quantum domain to the present lived experience of an agent. Here, a non-experienced fact is not a fact, just as a non-observed phenomenon is not a phenomenon, according to Wheeler, for instance. Accordingly, in relational quantum mechanics, the experimental information about a system is said to be relative to another system, namely to an object of the theory. Instead, in Cubism, the experimental information is relative to an agent in some given situation, namely to a meta-theoretical term, not a theoretical term. The status ascribed to the quantum theory and the quantum symbols is also quite different in relational quantum mechanics and Cubism. According to the relational interpretation, quantum mechanics is supposed to afford an indirect description of the world as it is, qua relational network. Instead, according to Cubism, quantum mechanics is a user's manual for an inhabitant of the world who has experiences of the outcomes of her own interventions in the world. Cubism thus considers that some laws of quantum mechanics are normative of our expectations about the outcomes of our interventions in the world, rather than descriptive of any aspect of the world. Now, Cubism is also a very composite interpretation that combines elements of pragmatism, phenomenology, and subtle realist aspects. So let me document now these aspects in turn. Okay, so there are pragmatist aspects of Cubism. In Cubism, a measurement is described in thoroughly relational terms. Here, a measurement is not the disclosure of a value inherently possessed by the physical system, but as the creation of some outcome resulting from the unpredictable interaction between a physical system and an agent who intervenes by means of a prosthesis called the experimental device. Yet, this description of the measurement looks very concrete and dualist. It sounds as if two entities, a pre-theoretical one called the agent and the theoretical one called the system, were already given out there and ready to interact. This is not the last word of Cubism, in fact, and I will now turn to the phenomenological aspect of Cubism. Actually, Cubism is struggling to show how all these representations, observations, and facts are realized in the lived experience of agents, so much so that the true primitive concept of Cubism might well be the phenomenological concept of lived experience, below the level of the pragmatist concepts of agent and intervention. So let's just read this sentence of Chris. The fundamental primitive of Cubism is the concept of experience. According to Cubism, quantum mechanics is a theory that any agent can use to evaluate his or her expectations for the content of his or her personal experience. End of quote. Jacques Pienard then went as far as considering that the dualist pragmatist structure of agent and system is in fact a projection of a non-dualist process within lived experience. I quote him, an experience contains as a fundamental internal structure a pairing of an experiencing subject with an experienced object. Such experiences are called events, end of quote. So here, the relation between subject and object is part of experience. And events or facts are themselves experiences. So much so that experience is taken as the most secure de facto, ultimate relatum of the relational meshwork of the quantum domain. Experience is so basic that it comes to be taken as an element of reality in its own right. But this doesn't prevent Cubism from defending a non-standard form of realism. For after all, the inner structure and unfolding of lived experience involves possible surprises, it involves expectations about unpredictable events, and the system of such expectations is submitted to non-trivial constraints if it should be submitted, in fact, to non-trivial constraints if it is to be made capable of accurately predicting future events. So here is the non-conventional form of realism of Cubism, which can be called an intra-realism. Normative constraints are to be imposed onto an agent's probability assignments, as I told you before. And these normative constraints do not reduce to the standard rules of probability theory that express a condition of inner coherence between the various bets of an agent. The aspect of the normative constraints that go beyond the standard rules of probability theory must thus express the resistance of something we can call vaguely reality. But this reality that exerts constraints and triggers resistance cannot be entirely disentangled from what agents do in it in order to explore it. This is why Chris Fuchs adopted the term intra-action from Karen Barad to express the agent-environment relation instead of the standard term interaction. Indeed, this relation is something at work within the recesses of a non-dualist reality. It is not a transient dualist connection between two distinct entities. Such non-dualist conception of the agent-environment relationality yields a conception of reality, an ontology maybe, which is remarkably close to the non-standard ontology proposed by French phenomenologist Maurice Merleau-Ponty. This ontology was called intra-ontology by Merleau-Ponty in his book Visible and Invisible, which evokes Fuchs and Barad's intra-action. Intra-ontology can be defined as an ontology of the participant in being, rather than an ontology of the observer of beings. Merleau-Ponty's definition of vision, which can be transferred to experimenting, is modified accordingly. Merleau-Ponty considers that vision is not the effect of the light emitted in outer space by some object separated from our eyes, conceived as bodily objects themselves. Instead, vision is defined by Merleau-Ponty as, I quote him in the slide, the tool which allows me to contemplate from within the vision of being, end of quote. So these remarks lead me to set out in detail the mesological or middle way status of quantum concepts according to Cubism. Every such concept is concerned, but I will just stress the status of quantum state vectors. The traditional debate about quantum states has opposed proponents of an epistemic status to proponents of an ontic status of quantum states. In the first case, the quantum state vector would express our partial knowledge and partial ignorance of the real state of the physical system. Instead, in the second case, the quantum state vector would rather describe the real state of the physical system. In both cases, as you see, one posits that there must be a real state of something independent of any process of acting on it. And in both cases, one accepts a dualist pattern of subject and object corresponding to the epistemic or ontic status of the state vector. But Cubism ascribes a completely different status to the quantum state vector, one that doesn't fit this dualist pattern. As Blake Stacey pointed out, the Cubist construal of a state vector is that it is neither epistemic nor ontic, but as he said, doxastic. Doxa means opinion in Greek. Then here, a state vector expresses an anticipated opinion of the agent about the creative phenomena that she will trigger by setting an appropriate experimental context. In shorter terms, a state vector expresses an anticipated opinion of the agent about the byproducts of her intra-actions. This non-dualist middle way is remarkably similar to the middle way between idealism and external realism, which is obtained by phenomenology through its radical suspension of judgment about any entity, called the epoche. It also evokes the Buddhist middle way between the idealist undertones of Chittamatra and the realist stance of Sarvastivada, obtained through a radical confutation of any view about the so-called inherent or the supposed inherent nature of things. So now, final thought, very quick thought, much quicker than in this slide. In this slide, I just recapitulated some elements of my comparison between relational quantum mechanics and Cubism, and also my connection of both of them to Madhyamaka. The difference between relational quantum mechanics and Cubism can be summarized in a few words. It is the difference between a relational view of the world and a relational dissolution of any God's eye standpoint view of the world. And the similarity between the Cubist and the Madhyamaka's dissolution of views of the world is that they both pave the way towards a sustained practice in the world. Thank you.
That was a lovely talk and a lovely, very clear, very clear distinction between the two ways, which I think is going to be very fruitful for us both, especially in unpacking the way Madhyamaka can relate to both of these theories, which I think are interesting ways to pursue things. My question for you, or just a comment, or just would like your feedback. So, the idea that Chris uses about that quantum mechanics is a user's manual. Yeah. I both like that and don't like that in some way, because the user manual somehow sort of takes away a little bit from the importance of it. I mean, I bought a refrigerator, here's your user manual. But it strikes me that really what is important about Cubism is that it's in giving us a user manual. What it's telling us is a user manual for the relationship between self and world, right? It's telling us that it takes physics from being something that's just about telling us about the nature of the world without us, to perhaps beginning to indicate the structures that separate, that are the residue when there's this pulling apart of inner and outer, or those views. And of course, those things are empty. But what quantum mechanics actually teach us about, or that's the lesson of quantum mechanics, is there still are structures. There's, like the rules of quantum mechanics are the structures that are the residue of this pulling apart that has happened. And I just wonder, and what's really interesting to me is thinking about how Madhyamaka or Dogen actually also in their own way have thought about those structures. So I just wanted to.
Yeah, thank you very much. Yes. And maybe I can give an illustration. Just if you learn how to swim in water, then you learn something about water, even though you have said nothing about the nature of molecules and so on. The way of swimming in the water and overcoming the resistance of the water tells you something about the water, but though indirectly.
Right.
And relatively, that's very small.
Michel, that was a great talk, and it will help me a lot in my talk. A quick comment. Actually, that verse, what is it, 13:8, the term at the end there, if someone whose view is emptiness, asadya is the term in Sanskrit, it actually means you don't accomplish, it doesn't mean you don't accomplish anything. It actually means you're incurable.
Incurable, yeah. It's even worse.
Yeah, it's a little stronger.
Even worse. Maybe I was not daring to say that.
So the medicine of emptiness can't cure you if you think it's real, so to speak. But that was a quick comment. But actually, my question for you is, I saw appear at a certain points, and this has come up a little bit in Chris's presentation, but not quite in this terminology, the term, I believe, both pure experience and pure appearance. And I'm just wondering, is there any difference between those terms? But mostly what I'm wondering is what you mean by them.
Yeah, well, this is a good and difficult question. I think that, when you say appearance, you think that something appears. So it's turned towards what appears, towards the objects that appear. Instead, when you say experience, usually you tend to say that it's a subject's experience. And that's the reason why these words are so difficult to manipulate, because in fact, when you use them, you irresistibly tend to promote a dualist view of the world, whereas our desperate attempt is to overcome it and to give a name to something that is neither on the one side nor on the other, which is really neutral. And that's the reason why, for instance, the famous philosophers of the Kyoto school, Nishida Kitaro and Nishitani Keiji, insisted that they wanted to remove this expression by William James, pure experience, and use other words instead. For instance, the pure space or the locus of absolute nothingness, or things like that, that sound a little bit more neutral. So it's a difficulty. And of course, as ever, you point the subtle things. John, thank you for the comment.
Thank you, Michel.
Thank you, Michel. Thank you for the presentation. So you're raising a lot of interesting points and this comparison between relationalism and relational quantum mechanics and empiricism, raising a lot of interesting questions. So I have two questions for you. The first one concerns the so-called Munchausen trilemma, sorry. And it seems to me that one of the problems you were raising there was with respect to relational quantum mechanics is the lack of ground for what are facts and what are relations and which one is more fundamental. It seems to me that this dilemma can be overcome if we take a moderate ontological structural position of the kind of Esfeld and Lama. So not the extreme eliminativist ontological realism of French, say, but a position in which you cannot talk about objects and relations separately, in the sense that objects are completely defined by the relations and vice versa, relations are vice related. So they are totally identified, and it's a problem of our language and our experience to keep up separating. So my first question is, what's your take about, if you know this proposal of Esfeld and Lam, and what is your reaction to the proposal?
I think that, of course, you can do that. Namely, you can say, okay, objects are relative to each other, and on the other hand, relations arise out of the interaction between two objects, and you can maintain this twofold structure, but you have to be clear that maintaining this twofold structure is an act of conceptualizing. So when you say that you can maintain such an ontology, such a composite ontology, I think you forget that it can only be maintained relative to a certain act of conceptualizing. So I cannot, in this case, I really cannot subtract the subject from that. And therefore, it's not a true ontology, or maybe it's an ontology in a very weak sense of just items that language posits, or that concepts posits. This would be my impression.
So yeah, so there is this democratization process in relational quantum mechanics in which there is no distinction between subjects and objects, I would say. I mean, all the systems are treated in the same manner. So I just want to take the opportunity also to ask another question, because it could be a limitation of our NUMB physicist way of thinking, and I would like to hear what you think about the following thing. One of your critiques to the relational quantum mechanics is that reality is associated with the sets of all possible relations, the network of all possible relations. And you were saying it's impossible. So thinking in terms of this network is not valid because it doesn't.
It's just a view from nowhere. So it's a little bit contradictory with the very aim of relational interpretation. And this was pointed out by Jacques Pienard in his paper. And I think I agree with him.
Very good. So my question is the following. In physics, we do this all that. Maybe this comes from Carlo because it's the physicist way of thinking. For instance, in physics, we think about the space of particles, the Fock space, as a limiting space. So the definition of this space is with a limit of infinite number of particles. And in the experience of physicists, you never deal with this abstract space. We always deal with the Fock space with a finite number of particles.
Yeah.
And so on. I can make other examples. For instance, in the general relativity is defined with a metric that is in fact an equivalent classes of metric. And this is infinite. So we always define the fundamental objects in physics through this limiting process. And we are fully aware that there are no physicists, no agent that can access those entities, and yet these are needed for the definition of our theories. So what would be the status of Fock space or
oh yeah, of course. Yes, I would like to. I would give exactly the same answer as the one I gave in Paris it was to David Wallace, namely these concepts and pictures of physics and especially quantum field theory are remarkably operative and useful. So please use them. Use even representations if you need them. Use even God's eye standpoint images if you really wish, but just be aware that they are just that, pictures, just that. So I think it's a Buddhist. Prescription, namely, okay, just be aware.
Yeah, but I would say that the reality and the network of relations has exactly the same status here. Thank you, Michel.
Thank you, Francesca.
So hi, Michel. It's Bob Sharp. And I think I'm giving the same thing that I did in Dartmouth. I loved the paper. I thought it was great, made many things clear. But the first part of the paper, the way you present experience or the subject as the condition for the possibility or an opening to the possibility of the world, that seemed to be in tension with the move that you make in the second part, where you begin to ascribe certain characteristics to experience, characteristics like non-duality, or that it has a structure, a kind of subject-object structure. From a Buddhist point of view, what you're doing there is conflating two different positions that are in tension, which is Madhyamika on the one side, which is not going to open its mouth about the conditions for the possibility, because the moment you open the mouth, it slipped between your fingers. And the Achata, which is saying that we have to give some kind of account of what that experience is. So I would just, I mean, there's no time to get into the discussion now. It would be wonderful.
Yeah, you are right.
But it seems to be conflating two things, which within the Buddhist tradition, they felt that there's a tension there.
Yeah, you're absolutely right. I should have said that indeed experience is the condition of possibility of an opening to the world, one, but that the contents of experience can have structure. And I just skipped these contents, you know. It's not experience itself that has structure. It is the content of experience that have structure. Oh, hi, Carlo.
Thank you, Janine. I'll try to be short. Thank you, Michel. This is I really enjoyed your talk. It's very good and very clarified. I just want to make a comment on the way it sounds to me. It's not in any sense a rebuttal or a defense of relational quantum mechanics. It's how your presentation sounds to my ear. First of all, I think it's very accurate in all the aspects, and I think it makes very clear also the kind of discussion that me and Chris has gone on in many time, and you reduce it to you got very philosophically and to the standpoint which is your philosophical realm. So let me say how it sounds to me. When you say that relational quantum mechanics implies a naturalized epistemology, my reaction is yes, exactly. That's exactly the case. Yeah. And when you say that because of that, there is a circle, there is this how do you call it, Munchen trilemma. Three possibilities, all of which are difficult. I say yes, of course, exactly. And one of this is circularity. Okay, and then you escape from circularity because you say, okay, I don't want this circularity. And I think that's where I say, yeah, I do want that circularity. That's exactly what I want. I want the circularity because I don't want a foundation. I don't think that the foundation is, in my eyes, defensible. I do not find, I love pre-critics Kant. I find the critical Kant is wonderful. It's useful only when I naturalize it. When I say an agent that has this property can have knowledge only if, but as a transcendental position, I don't find it convincing because it leads to a priori things which I don't share. And when you go to phenomenology, and that's a key point, it seems to me from my perspective, it's not a criticism, but from my perspective, what you're doing is saying, I need a fixed point to start from. I need to put my feet somewhere. And the pure experience, the phenomenon of phenomenology can be that. And my own reaction, both as a physicist and as a completely ignorant reading of Nagarjuna, is why do you want a fixed point? Why can't you embrace, wait, let me finish. Why can't you embrace this lack of a fixed point in which circularity is there? And in particular, the only slight bemol that I would, perhaps now and not in the past, make it different in your presentation of relational quantum mechanics, is that I will not, you were not on my talk, I suppose, yesterday. I would emphasize that the structure of systems in relations, it's itself strongly determined by the way we arbitrarily, conventionally partition the world in fact. So it's itself conventional and itself relatively to a description. And this, of course, puts us in a lack of a ultimate reality that we can put it there as our final understanding of the structure of the world. But that's fine. What's wrong with this? We can live with it. So with respect to you, I would embrace the circularity, talk about experience, but not about the pure ultimate experience on which to ground the rest. Just view it as something which I can put as both as a starting point or naturalizing epistemology, trying to close the circle and reinterpret it. So in other words, there's nothing wrong, I think, in seeing Chris agent as just one of the systems of the world that interact with the other in the way it does, just with a little more brains and memory. And therefore, naturalizing epistemology without the fear of being simple. That's the way I react to that. And give up the ultimate reality.
Okay. Thank you, Carlo. But you know, to me, when you establish a circle such as this one, you just forget from where from you are looking at the circle, and you have a standpoint on the circle. You imagine yourself as external to the circle of observer and observed, which is typical of the naturalized epistemology. And therefore, in fact, you absolutize something without really knowing it, namely that you are the one who describes from outside the circle. Instead, when you posit experience as a starting point, it's not an absolute foundation, because experience is precisely, it's the name of the most fleeting phenomenon that you can have. It's something that doesn't stay, whose content is always flowing. So it's not a foundation, but it's our effective departure point here and now in this flow. So I don't think I try to invent a new foundation. I just, and I said that in my talk, I just tend to posit an effective starting point and give a name to it. And it's perhaps my mistake, I would say. I accept a mistake here, and a big one. And I think it was pointed out by Bob Schaff, is just to give a name to it. Say, oh, this is experience. Oh, yes, but when you give a name to it, you have the feeling that it's an entity and that it becomes a foundation. And it's not what I want to say. But at any rate, I must, Carlo, just a word. I think your interpretation is an amazing advance in the interpretation of quantum mechanics. I just wish to make one more step with respect to it. Thank you, Carlo.
Thank you so much, Michel.
I need to begin with a disclaimer, which is obviously I'm not a physicist, and I'm not a philosopher of physics, and I'm not a Buddhist scholar, though Buddhist philosophy is very important to me. I am a cognitive scientist and philosopher of mind who also works a lot in phenomenology, and I'm interested in cognition and consciousness, and so that's the perspective from which I'm going to be talking to you today about the subject of time. It's often said that physical time does not flow, and that the impression that time flows or passes is an illusion. Physical time is supposed to be objective and real. The flow or passage of time is supposed to be subjective and apparent. Given this viewpoint, the problem of relating physical time to experiential time is to explain how the illusion of the passage of time arises. Lately, some philosophers have looked to Buddhist philosophy to help with this question. The idea is that the illusion of the passage of time comes from the illusion of being an enduring self, an illusion that Buddhist philosophers have been especially concerned to analyze. Referring to Buddhism, J. David Velleman says, this is an absolutely marvelous paper, by the way. It's just a gem of philosophy, so I encourage you to read it. Very accessible, not too long. He says, seeming to be an enduring self, even though one is not, is what makes time seem to pass, even though it does not. And Craig Callender writes in his very rich book, the illusion of the enduring self is responsible for the illusion of the flow of time. Here's the Buddhist part. Buddhist philosophers argue that seeming to be an enduring self is an illusion that arises from our ignorance of how the mind works and our craving for permanence in a universe of radical impermanence. There's no enduring subject of experience, no subject that exists as a whole at each moment of time and passes from one moment to the next. Rather, there's just a series of mind moments, each consisting of a momentary awareness or consciousness and associated mental factors. Although we instinctually take ourselves to be an enduring subject, the existence of an enduring subject is an illusion. Velleman builds on this Buddhist idea by saying that the illusion of being an enduring subject gives rise to the illusion of moving in time. The illusion of an enduring subject arises from re-identifying the subject at earlier and later times in memory and anticipation. But this re-identification is an error because there is no enduring self-identical subject. The illusion of moving in time arises from the illusion of existing in one's entirety at each moment and moving in one's entirety in relation to events. So the two illusions go together, with the illusion about the self underpinning the illusion about time. I want to present a different way of thinking about the self and time. My approach begins by inverting the order of priority from physical time to experiential time. The experience of the passage of time is the ineliminable source for the meaningfulness and intelligibility of time as described in mathematical physics. Call this the primacy of experiential time. Looking closely at experiential time will help us to see that it's backwards to say that the impression of being an enduring subject generates the impression of time's flowing. Rather, the impression of time's flowing underpins the impression of being an enduring subject. But my argument goes beyond upholding the primacy of experiential time. I also want to argue that we are forever caught up in a strange loop that goes from experiential time to physical time and back again. Physical time and experiential time are interdependent, and there's no way to pull them apart. Okay, so here's an outline. I've just given you the introduction, and I'll flag these as we go through them. So I want to begin by saying some things about duration. My starting point is Bergson's concept of duration, la durée. Duration is his word for experiential time. His key idea is that time is not space. When we think of time as an ordered series of mutually external points, we spatialize time. We conceptualize time as a succession of discrete, homogeneous, and identical units. This is clock time. But of course, we never experience time this way. An hour in the dentist's chair is very different from an hour over a glass of wine with friends. This is lived time. Lived time is becoming. Once we spatialize, or really we should say geometrize time, we lose becoming. There is no becoming in a succession of homogeneous and identical units, points on a line, seconds on a clock. We lose the qualities of heterogeneity, each moment is qualitatively unique, and interpenetration, past, present, and future moments enfold each other. Music is a good example of what Bergson means by duration. A melody exists only in duration. It has no being either at an instant or as a series of discrete instants. Each note has its own distinct individuality while blending with the other notes and silences that come before and after. Past notes linger in the present ones, and future notes already sound in the ones happening now. Even musical pieces that emulate discrete seriality can't escape having their distinct elements meld into the intervening silences and pauses, and thereby also into one another. Music is inherently durational. Bergson insists that duration, properly so called, cannot be measured, and that as soon as we try to measure it, we unwittingly replace it by space. His reasoning has to do with the nature of measurement. To measure something, we need to stipulate the unit of measurement in terms of a standard. For example, the standard meter was once stipulated to be the length of a particular platinum bar kept in Paris, but now it's identified as the length of the path that light travels in a vacuum over an extremely short interval of time as measured by an atomic clock. Notice that the standard meter, which is a measure of length, itself has a length. The length of the platinum bar, the length of the path of light. The standard unit itself exemplifies the property it measures. Bergson argues that this procedure won't work for duration. If duration is to be measurable by a clock, the clock itself must have duration. It must exemplify the property it's supposed to measure. Of course, we think of clocks as enduring temporal things, but Bergson asks us to take a closer look. Any state of the clock, any position of the oscillating pendulum in his example, is external to every other state, like the points on a line or the numbers on a clock face. A clock can be described as a finite state machine in which every state is external to every other one. Every state is a position in space juxtaposed to another position in space. Every state is simply now, but with nothing left of the past. The past states don't continue in the present state. The preceding oscillation of the pendulum isn't held together with the present one while being registered as past. We hold them together in our memory, but the clock itself can't do this. But without holding together the past and the present, duration can't be registered. All that can be recorded is one non-overlapping state and then another one, but the sequence can't be registered because that requires memory, the holding of the past and the present. Memory, however, is part of the consciousness of duration. The consciousness of duration always includes within its now the trailing threads of the immediate past. Husserl calls this kind of memory retention, and he says that the apprehension of the now is the head attached to the comet's tail of retentions. The clock, however, has no memory, it lacks duration, and so can't measure it. Now, Bergson isn't denying that we can measure time. On the contrary, his point is that clocks don't measure time, we do. A clock face showing 10:59 and then showing 11 isn't measuring time. Measurement requires that we look at the clock, read the numbers, and notice there is a change. We must hold the prior states of the clock in our memory, in our consciousness of duration. Take away the measurer's memory and you no longer have a measurement of time. Clock time presupposes lived time. Bergson appreciates that we need the exactitude of clock time for natural science. What he objects to is the surreptitious substitution of clock time for duration, of geometrical magnitudes for temporal qualities, of instants for moments, in our metaphysics of time. The crucial point is that measurement presupposes duration, but duration eludes measurement. The experience of duration is a necessary precondition for the intelligibility of clock time. Next section, coarse graining. At this point, you may have the following objection. Isn't our sense of passage and duration and the now a cognitive construction arising from a measurable physical system, namely the brain? Isn't our experience of duration the result of the brain's doing something like coarse graining, smoothing over fine granular details by simplifying them? For example, whether two stimuli are judged as simultaneous or sequential, or as one stimulus in apparent motion, depends not just on their interstimulus interval, the time between them, but also on when they are presented in relation to the phase of ongoing spontaneous brain rhythm. So same interstimulus interval presented differently in relation to ongoing, say, beta oscillation, phase of beta oscillations gives you different temporal judgments. So why can't we say that our passage of time, why can't we say our sense of passage is explainable as a result of the brain's coarse graining activity? My answer is that this kind of explanation as a matter of principle is partial, not complete. Cognitive neuroscience research on time perception proceeds by applying clock time to outwardly available neurophysiological correlates, behavioral manifestations, and verbal reports of experienced time. Although we learn valuable information about how the brain parses time, we don't explain duration in the sense of showing how brain activity, described strictly from the outside in third-person terms, suffices for the subjective experience of duration. To think that neuroscience does give this kind of explanation is to think that neuroscience has solved how the problem of consciousness is generated in the physical world. But that's not the case. There remains an explanatory gap when you take that, or attempt to take that kind of third-person point of view. So here's what's really going on. Scientists relying on their own first-person experience of duration, including when they read clocks and measure time intervals, apply clock time to observable biological and behavioral processes, and then infer back to aspects of duration that they can extract and stabilize as objects of thought and attention in their own lived experience, and describe in intersubjectively agreed upon ways. They work entirely inside the inescapable, strange loop of experiential time and physical time. They never step outside of lived time and explain it in terms of something else. So for these reasons, it's wrong to think that Bergson's idea of duration can be assimilated to the idea of psychological time as opposed to physical time, which is the standard way that people describe Bergson, where psychological time means clock time applied to perception. Time as defined in physics as what a clock measures can't be detached from time as passage as given in the experience of duration. Clocks require clock readers, clock reading requires consciousness, and consciousness is durational. Okay, so that brings me to the Bergson-Einstein debate. And Yamina Canales has written a marvelous book about this from a history of science perspective, and I want to kind of go into just one aspect of the debate, very complicated debate actually, especially if you read Bergson's Duration and Simultaneity. I want to go into one aspect, really kind of an underlying philosophical aspect that is mentioned in her book, but I want to sort of emphasize it more. All right, so these ideas figured then in Bergson's debate with Einstein. Bergson argued that the relativistic definition of simultaneity presupposes the experience of simultaneity in the consciousness of duration, the experience now, and that this experience, these are Bergson's words, does not depend on any mathematical convention, on any physical operation such as the setting of a clock. Einstein dismissed this, saying it concerns only psychological time. And this is in a way the root of dealing with, that way of dealing with Bergson, trying to make it a point about psychological time. But I think he missed Bergson's point. Or if he got it, he didn't want to acknowledge it. Bergson's argument was that we can't make sense of the concept of clock time without referring to something that is independent of the reading of a clock. Namely, these are Bergson's words, the moment in which we find ourselves, the event that is occurring. You could say the now. Which we know only as the now of duration. The now is the moment in which any clock must be read. Again, clocks don't read themselves. We must experience time as duration in order to abstract time as a measured point in the abstraction of a space-time diagram. Our experience of time precedes, logically and conceptually and epistemically, the mathematization of time needed to build a clock. Now, some physicists and philosophers deny this. They say that the observer in relativity theory doesn't have to be a living being or a conscious subject, but could just as likely be a photographic plate or a clock. Those are words from Bertrand Russell's book on relativity, or a computer. This has to do with the issue that Bob raised yesterday about is it sentience that's involved or not in the discussion, I think, with Carlos' talk. So some physicists and philosophers make this move. The observer doesn't have to be a sentient being. I don't see how this could be true. Nature doesn't produce measuring devices except via human beings and their intentions. Measuring devices according to standards, precise standards. Unless what the photographic plate or clock or computer registers is itself registered in experience, it seems it has no scientific meaning. Bergson had no objection to Einstein's operational definition of simultaneity. Two events are simultaneous in a given frame of reference if they occur at the same time as measured by clocks that have been synchronized using light signals. Rather, he was arguing that the intuitive concept of simultaneity, the experiential concept, based on the experience of duration, lay beneath Einstein's operational definition, where it functioned as a hidden source of meaning. Einstein, in his famous 1905 paper on the electrodynamics of moving bodies, had claimed to have operationally defined simultaneous, synchronous, and time using certain imaginary physical experiments. Those are Einstein's words in English. At the end of the section called Definition of Simultaneity, he wrote, "The time of an event is that which is given simultaneously with the event by a stationary clock located at the place of the event, this clock being synchronous and indeed synchronous for all time determinations with a specified stationary clock." This definition uses local simultaneity between a local event and a local clock to define the simultaneity of clocks at a distance. But local simultaneity depends on the direct experience of perception and the now. A physical event, such as a ball hitting the ground, is said to be simultaneous with a local clock reading because the two are perceived to happen at the same time. Thus, perception, the direct perception of the now given in the experience of duration, underlies Einstein's definitions. So the definitions can't claim to be completely objective or third-person ones in the sense of using only objective procedures or tests and not depending on subjective experience for their meaningfulness, and validation. This was the point in the exchange between Bergson and Einstein of Bergson's example of the intelligent microbes who would perceive a lack of simultaneity and an enormous distance between what Einstein would regard as simultaneous neighboring events, a train pulling into the station while he looks at his watch. For the microbes, there is simultaneity only if they perceive a local event to be simultaneous with a reading of their microbial clock. So Bergson was making 2 points here. First, what counts as local versus distant is inexact and relative and depends on the observer, and Einstein admits this in a footnote in his 1905 paper. Second, and more importantly, the ability of the scientific microbes to measure simultaneity by synchronizing clocks using light signals would presuppose their own perception of local simultaneity in their experience of duration, there now. The experience of duration, which is to say experience itself, is ineliminable and can't be removed by Einstein's operational definitions. On the contrary, those definitions presuppose it. Now, for Einstein, of course, the final test was whether his theory worked. Explicitly acknowledging the experience of duration, the lived now, which actually bothered him quite a bit later in his life, in his reflections, as recorded in a conversation with Carnap, if I remember correctly. In any case, explicitly acknowledging this wasn't directly relevant to his theory, so he abstracted away from it. And there's nothing wrong with that. The philosophical mistake is to think that his definitions of physical time are more fundamental than the experience of time. This is what Bergson would not allow. Thinking that, so now this is the section called the blind spot. Thinking that physical time is more fundamental than experiential time is an example of what Adam Frank and Marcelo Gleiser and I call the blind spot. And this is the shameless self-promotion moment for the forthcoming book that we are nearly done writing. And Michel Bitbol has also written about the blind spot and used this expression. The blind spot is the failure to see that direct experience lies at the heart of science and makes science possible. So any science that tries to supplant experience by reducing it to or eliminating it in favor of abstract and idealized constructs undercuts itself. The blind spot occludes experience through the following interlocking steps. The first is what Husserl called the surreptitious substitution. This is his term for replacing the concrete world of perception with the abstract and idealized entities of mathematical physics. These idealized entities, free-falling bodies, frictionless planes, hypothetical ideal gases, perfectly elastic collisions, these aren't physically real. They don't participate in causal interactions. They're fictional entities we use as tools. So thinking that the idealized laws of mathematical physics describe the concrete being of nature is misguided. Thinking this way, as Husserl says, is to take for true being what is actually a method. This is the surreptitious substitution, the substitution of a tool to describe phenomena for nature itself. It's a kind of category mistake. Substituting clock time for duration or nature at an instant for nature as process is a case of surreptitious substitution. Fallacy of misplaced concreteness, this is Whitehead's term for treating mathematical abstractions as if they were concretely real and proposing to reduce the concrete to the abstract. This nonsensically reverses the dependence relation. The abstract presupposes the concrete. The fallacy of misplaced concreteness and the surreptitious substitution go together. It's worth pointing out, by the way, that both Husserl and Whitehead were mathematicians. They were philosophers, of course, but their work and formation was mathematics. So they were speaking as mathematicians as much as philosophers. Thirdly, reification of structural invariance. Science produces structural invariance through abstraction from experience. For example, by extracting what is invariant under transformations between perspectives. Such invariants are highly distilled residues of experience. That's actually Michel Bitbol's term. Reification happens when they are regarded as essentially non-experiential structures that constitute the intrinsic structure of being. And then lastly, amnesia of experience. Once we reify structural residues of experience into non-experiential entities, experience drops out of sight completely. It now lies hidden in the scientific blind spot we've created by treating the products of a method as if they reflected reality or being in itself apart from our modes of experience and action. In the case of time, the blind spot's most extreme form is declaring that the experience of an ever-renewing now, which is the indispensable touchstone for any empirical investigation of nature, is an illusion, and that all of space-time is a four-dimensional block. The block universe theory epitomizes the blind spot. How is it possible to formulate coherently a conception of the contemporaneous reality of all the events contained in the block universe without adopting an impossible God's eye perspective external to the universe and the passage of nature? The block universe theory surreptitiously substitutes spatialized time for temporal becoming and treats an abstract mathematical representation as if it were the intrinsic structure of being, thereby falling prey to the fallacy of misplaced concreteness. The block universe theory reifies space-time by turning the process of becoming into a thing. This is to confuse a mathematical picture with what is being pictured, the map with the territory. Okay, so the subject of flow. We're moving back to the self now. The statement that the illusion of an enduring subject is responsible for the illusion of flowing time moves within the ambit of blind spot metaphysics, because it takes the block universe theory, including the growing version of the theory, growing block version of the theory, as its metaphysical starting point. This is pretty clear in Velleman's paper especially. But if we recognize the blind spot for what it is, then we have to attend to the wellspring of experience that it occludes and that is actually the source of science. We have to invert the order of philosophical priority from abstract and idealized physical time to experiential time. It's there, within the workings of experience, that we need to look to find clues about the temporality of time, its ever-renewing and flowing now, what Bergson calls duration, and how this relates to subjectivity and the production of objective knowledge of which science is the model. Now, we also have to be careful to distinguish between the confused common sense conception of time as flow, where we liken time to a river we're watching flow by from the riverbank, thereby placing ourselves outside of time, and a proper phenomenological analysis of flow, for which, as Borges says, time is a river which sweeps me along, but I am the river. Now, this opens up a vast topic in phenomenology, the topic of the consciousness of time, which was inaugurated by Husserl in his 1905 Lectures on Time Consciousness, the same year Einstein published his 4 papers that transformed science. It's worth remembering that Husserl's project was to show how objective time, the time of the world as understood by physics, is epistemically constituted out of experiential time. It was this project that led him down the path of plumbing the depths of what he called the consciousness of internal time. Of course, there's also a growing literature in analytic philosophy of mind and cognitive science on the consciousness of time, and it's an area where not just Buddhist philosophy, but also Indian philosophy altogether is relevant. And here I'm thinking especially of the debate between the Buddhist philosopher Dharmakirti and his followers and the Shaiva philosopher Bhatta Ramakanta about whether consciousness is momentary or enduring, and hence whether our impression of consciousness as enduring is illusory or veridical, and whether or not there is an enduring subject. So all of that, phenomenology, analytic philosophy, cognitive science, Indian philosophy, all of that goes beyond the scope of what I can talk about here. I want to focus just on the claim that the impression of an enduring self is responsible for the impression of flowing time. From a phenomenological perspective, this claim is backwards. It's rather the case that the impression of flowing time is required for the impression of being an enduring subject. Take the experience of hearing a melody, a morning raga played on the sarod. Each note figures in a phrase heard all at once as rising and subsiding, while new notes arrive at changing tempos. According to Husserl's analysis, retention is the function of consciousness that presents the notes as becoming past while you hear them sound. The just past notes trail off, but they're retained in the phrase you currently hear. They're not retained as present, otherwise you would hear them as a chord, but rather precisely in the mode of becoming past, so that they form a flowing sequence. In this way, you perceive the just past notes in their flowing away. At the same time, you anticipate the notes that are arriving. This anticipatory function is called protension. The flow doesn't just leave a wake in retention, it leans into the future in protension. In cognitive science terms, this is very like very short-term memory and forward modeling, which are built into perception. But the phenomenological story is more complicated. First, every retention is also the retention of prior retentions. So there is a retentional continuum that is sinking back and fading with diminishing affective vivacity or valence. Second, every retention is also the retention of a protension, including the degree to which that protension was fulfilled, that is, expected and confirmed. Third, every protension is also the protension of a retention. It's an anticipation of something as to be retained. So past and future thoroughly interweave. Finally, the retentional-protensional interweaving is inherently reflexive. You hear the notes sounding and sinking into the past by retaining your awareness of listening to them. More generally, any given now phase of consciousness retains the just past phase of its temporal object, the just past note, by virtue of retaining the just past phase of consciousness, the just past auditory awareness. So awareness of objects across time, notes, depends on consciousness retaining itself, being implicitly self-aware in retention. Now, one of the upshots of this analysis is that experiential time can't be laid out on a line because its phenomenal structure is nonlinear, recursive, reflexive, and self-affecting. This is actually what Francisco Varela tries to depict here using the idea of metastable flows and transients from complex dynamical systems theory. This is a whole article in which Francisco relates Husserl's analysis of time consciousness to ideas in neurodynamics. This is also what Merleau-Ponty means when he says time is not a line, but rather a network of intentionalities. Although Husserl repeatedly tries to diagram time consciousness using lines and triangles, I showed you an image of this before, his actual analyses reinforce Bergson's point that experiential time resists being spatialized or geometrized. Another upshot is that there is a sense in which the subject can be said to endure, but not as an entity, but rather as a dynamic constant of a process. As we live through events in the renewing now, with its retentions and protensions, the reflexivity of time consciousness, its being pre-attentively self-aware and self-affecting, remains in place as an invariant structure. Husserl calls this structure standing streaming, because the standing, that is the invariant structure, makes possible the appearance of streaming, of time's flowing. Now, whether this invariant structure suffices for a subject or a self is partly a semantic matter. So on one side, you have phenomenologists like Dan Zahavi today and Husserl, who say that reflexive awareness suffices for a minimal self or a minimal subject. That's Dan's expression. On the other side, Buddhist philosophers who subscribe to this idea of reflexive awareness, Svasamvedana or Svasamviti, not all Buddhist philosophers do, they deny that reflexive awareness suffices for a self. They consider consciousness to be momentary, so each moment of reflexive awareness is strictly unique. Nothing passes from one moment to the next, and hence nothing, properly speaking, endures as a subject. Opposed to them are the Shaiva philosophers, like Bhatta Ramakanta, who argue that consciousness isn't momentary, and who regard reflexive awareness as a dynamic constant of a continuous process, and hence as sufficient for an enduring subject. And Bhatta Ramakanta's position is actually very close to Husserl's, at least Husserl's in the 1905 lectures. Now, We don't have to take sides on all of these issues. I mean, it'd be fun to do so, but I'm not going to try to do so now. To see the problem with saying that the impression of the flow of time comes from the impression of being an enduring subject. It's rather the other way around. First, the impression of the flow of time comes from the retentional-protensional structure of consciousness. Second, that structure already constitutes a minimal sense of being an enduring subject, a subjectivity with a feeling of duration from one moment to the next. Third, that sense of being an enduring subject is a necessary prerequisite for the more complex sense of narrative selfhood, which requires being able to self-identify in episodic memory and anticipation. That more complex sense of being a subject is metacognitive. You cognize your own cognition as represented in the past, identifying it with your past self, which is the same as your present self recollecting. That's a metacognitive structure that's very actually complex, cognitively speaking. So the point here is that metacognition of that sort doesn't give rise to the impression of flowing time, rather it depends on it. Now, Velleman himself uses the example of a melody to illustrate his thought that the subject perdures rather than endures. So this is a philosophical nomenclature. That is, the subject extends in time by adding newer and newer temporal parts to fill each successive moment, rather than enduring as a whole through time. But that kind of perdurance isn't enough to account for a melody, let alone a subject. A melody is not a mere succession of notes. A melody is a unity. It's a one in the many that depends on a temporal synthesis. Mere perdurance isn't sufficient for temporal synthesis. Velleman says, if you could learn to experience your successive moments of consciousness as successive notes in a performance with no enduring listener, then you would have no experience of being a single enduring subject. I think this is wrong in two ways. First, there's an ambiguity here between hearing successive notes and hearing the notes as successive. The former, hearing successive notes, isn't sufficient for the latter, hearing the notes as successive. As Kant said, a succession of states of consciousness, corresponding to each note, isn't sufficient for a consciousness of succession. There needs to be a temporal synthesis to experience the notes as a melody. Second, Velleman seems to think that you could experience the successive notes as a melody even if you didn't experience yourself as an enduring listener. You could lose the illusion of being an enduring subject and still enjoy the melody. That seems wrong, at least to me. The temporal synthesis that enables you to enjoy the melody is effected by the retentional-protensional structure of consciousness. And that structure automatically gives rise to experiencing yourself as an enduring subject. In short, to experience hearing a melody is to experience yourself as an enduring listener. Okay, now, up to this point, I've been talking more or less within a subject-object framework. A listener and a melody construed as subject and object. And that's pretty much Husserl's framework, at least in the 1905 lectures. Later, Husserl is a much more complicated story. In those lectures, Husserl prioritizes the subject. Consciousness generates the appearance of flow and constitutes itself as an enduring subject through its own reflexivity, regardless of the objects or contents of consciousness. And this is why Husserl calls the flow absolute subjectivity. Merleau-Ponty, however, moves away from this conception and towards a perspective closer to Buddhist philosophy, particularly Yogacara philosophy. He says that retentions and protensions do not emanate from a central I, but rather from the anonymous or pre-personal perceptual field. He calls the perceptual field, understood especially in light of its temporality, a field of presence. And he says that subject and object are abstractions from the unique structure of presence. In other words, the field of presence doesn't inherently have a subject-object structure. Rather, subjectification and objectification happen in one stroke when we reflect on presence. To put the point another way, the ever-renewing now, the field of presence, lies deeper than the subject-object structure and is a condition of possibility for subjectifying and objectifying mental acts, such as retrospective metacognition. Now, this is reminiscent, in the sense of an analogy, not an identity. This is reminiscent of Vasubandhu's three natures theory. The appearance of consciousness as having a subject-object structure is, in the three natures framework, the so-called imagined nature. The causal flow of phenomena is the dependent nature, and the complete absence of the imagined nature, that is the subject-object structure, in the dependent nature is the consummate nature, or the perfected nature. For Yogacara, however, the subject-object structure, or at least for some Yogacara thinkers, the subject-object structure is already present as a distortion of non-conceptual sense experience, whereas Merleau-Ponty sees it arising mainly as a result of reflection, which is conceptual, because it involves recognition, having recognitional concepts of your own mental states, for your own mental states. But Merleau-Ponty moves still closer to Buddhism in his late writings. There he says that the problems he had posed in phenomenology of perception were insoluble because he had started from the subject-object distinction. Instead, he now uses the expression time being, le temps être, and this is reminiscent, indeed you could say it's a translation in French, of Dogen's term uji, which is also translated as time being or being time, depending. In both cases, time being is meant to indicate the non-duality of mind, body, being, world, and time. Of course, Dogen, as a Buddhist, is working from a conception of time as momentary and discrete. Thus, uji, time being, has also been translated as existence moment. Nevertheless, Dogen's moments are a far cry from the Sautrantika Abhidharma abstraction of dimensionless instance. Dogen's moments are living ones in which past, present, and future interpenetrate, and this is coming from Huayan Buddhism, so they would seem to contain duration in Bergson's sense within them, or to be living presence with immanent flow in Husserl's sense. Husserl uses this expression, the living present. In any case, these conceptions imply that we need to distinguish again between the common sense conception of the flow of time, which all these thinkers agree is confused and reified, and deeper phenomenological understandings which point back to the primacy of experience and its generative sources. Okay, last section. I've been emphasizing the primacy of experiential time as a corrective to the blind spot. But I want to end by bringing physical time back into the story and by calling attention to the strange loop of experiential time and physical time. The term strange loop, of course, this comes from Douglas Hofstadter, but my thinking here has also been very influenced by Bob Scharf's writings about the looping structure of Buddhist thought. Okay, so let's go back to Bergson. As several philosophers of science have recently suggested, Bergson's idea of duration is compatible with relativity theory if duration is understood as the passage of local or proper time, the time measured by a clock following along the world line within a reference frame. More precisely, if proper time is understood as a mathematical abstraction based on the experience of duration, understood as local passage, then Bergson's perspective can be brought together with relativity theory. And this is really what Bergson was trying to do. He didn't want to contest Einstein on his own grounds. He wanted to in a way, this is an anachronistic way of putting it, obviously, but in a way he wanted to show how Einstein's theory, properly understood, should be understood as post-blind spot science, but it wasn't being understood that way. And so he was trying to do that through his concept of duration. He made some mistakes in doing this, famously with the twins paradox, and so that has gotten lost sight of. In any case, if proper time is understood as a mathematical abstraction based on the experience of duration understood as local passage, then Bergson's perspective can be brought together with relativity theory. And when we do that, we reinforce the idea that duration is always situated. The passage of time is always given from some experienced perspective in the universe and never from outside it. Each world line reflects a unique passage and possible experience of duration. Better still, each world line represents the abstract distillation of a unique durational flow, since a world line is a mathematical abstraction, a structural residue of experience, in Michel Bitbul's terms, whereas duration is concrete. Given that there is no non-arbitrary upper bound on the number of world lines and associated proper times, the universe is teeming with times and potential durational rhythms. The crucial point is that there is no such thing as a temporal bird's eye view of the universe that ignores the differing rhythms of passage constituted by the disparate paths through space-time. That point counters the blind spot, which, by occluding the ineliminable presence of experience, makes it seem that there is such a bird's eye or God's eye outside view. So we're now confronted with a strange loop. To say that duration is always situated brings the living body to the fore, because the living body is what makes duration situated. On the one hand, experiential time has primacy, because it's the horizon of all knowledge. You can't step outside the horizon of experience, because experience is the context within which any knowledge happens. On the other hand, the body subsumes experience. On the one hand, we can't step outside experience and take up a God's eye view. On the other hand, experience must have bodily sources that exceed it and that it can never fully fathom. Experience exhibits both closure, like a Klein bottle or a Möbius strip, and transcendence. It intrinsically points beyond itself and seeks to expand its range. There's the horizon. You know you can never reach it, but you know there's always something that lies beyond the horizon, and if you keep walking, you will open up a new vista with a new horizon. In the case of time, experiential time depends on physical time that we model and measure through experiential time. That sentence comes from Marcello, actually. I have to give proper credit to Marcello for that sentence. Here we recover the truth of the brain's coarse graining. Experiential time depends on neurobiological time that we model and measure through experiential time. That's the strange loop. The blind spot hides the strange loop so that we forget it. We come under the spell of thinking that it's possible to grasp time or consciousness from a purely outside vantage point, one outside of the strange loop in which time and consciousness place us. What I've tried to show is that we can use insights from Buddhism, physics, and philosophy to reveal the strange loop as a hidden source of science and experience. Thank you.
Thank you very much for that talk. That was super interesting. And hopefully through this conference I can ask the 15 different questions I have. I'm torn which question to ask. I really want to ask one about the clock stuff at the beginning, but let me just try to ask something more about the stuff at the end. That's super interesting about the kind of self inside the experienced subjective present. But I wonder whether this sort of thinking, I don't know if it's another perspective or puts pressure on this, or I wonder how you react to it. So if we think about animals, so some people think that what makes human beings distinct is that we have the ability to mentally time travel. Right? So we have through memory I can go back, through anticipation I can imagine myself at lunch later, and that maybe what animals or some animals are doing is that they're like updating on, a subjective present is being assembled and then they're updating on that, and they're not doing this kind of projecting through time. And so my dog Odie, he gets temporal information from these assembled presents, like the sort of sand clocks, people have notes patterns and stuff like this, but he's not projecting Odie forward. And so now, when I think, so does Odie have think that time flows? So in your view, it seems like Odie, you know, because he's got all this kind of, in his subjective present, he's got all that kind of vectorial information coming in. And so he's got all his changes and all that stuff. So maybe he doesn't recognize melodies as such, but he's still, you know, able to chase a cat and stuff like that. So does he think time flows on your sense, but then he wouldn't think time flows on sort of Velleman and my sense, where it's a more cognitive thing, how to do more of this mental time travel.
Right. Okay. Great. So we need to distinguish between the metacognitive sense of the self that involves mental time travel, which obviously is fundamental for human beings, and some other animals may be capable of, may not be. This is kind of an open question, as I'm sure you know. And then the sense of a more, let's say, I'm going to assume that your dog doesn't think that time flows, but in the sense of flow that I was talking about with the retentional protensional structure, that would seem to be more basic, and I would even be willing to go out on a limb and say maybe architecturally basic to sentience or consciousness, in which case I would say, yes, the dog does experience that. And so in that sense, there would be a sense of flow and a sense of being a subject or subjectivity that would be not metacognitive and conceptually metacognitive. But we could say, well, concept is a tricky word. Let's leave that out because it depends on what we mean by concepts. But let's say it's not metacognitive, but it would be, we could call it a kind of first order experience of flow that's not the second order metacognitive one.
Very interesting, Evan, and I guess I have kind of two connected things. So one of them, I'm not sure I agree with you on Dharmakirti. So just in brief, the way to think of it is that actually the present does have the past in it, experientially, because the present moment of experience is the causal result of the immediately presenting moment, and precisely the reason that we can engage in a metacognitive at a very low level. So this is where concept, gets tricky, but it's a very low level and not actually, it's almost like sub-phenomenal act of stringing those moments together into a sense of a self in time. That is, the reason that works is that those moments exhibit a similarity because they're in a causal stream like that. So like if they were radically different, that wouldn't happen. Right. So in that sense, I think there is, Dharmakirti is not saying it's like discrete moments that have nothing to do with each other.
Right. Oh no, I didn't mean it in that sense. I was really thinking of the debate between, or I was thinking of how Bhatta Ramankanta sort of takes up the idea of the reflexivity of consciousness and then tries to argue that consciousness is continuously enduring rather than discrete and momentary.
Right, and that's where, and so here's, Dharmakirti does something similar, which is actually reflexivity is necessary for this sense of continuity, but it's not sufficient. So what you need with, and this is what leads to the second part of my question, what you need with reflexivity is intentionality. Yeah. So if you have that, and as you said, like for Dharmakirti and other Yogacaras, and I think you don't have to hedge your bet. Every whole Yogacara is going to say this is not a kind of conceptual. This is given with experience and ordinary people, right? But they think it's an error. And it's not what's really going on, so to speak. So once you have that in place, then reflexivity kind of, in a sense, automatically induces this, construction, very low-level conceptualization, quote-unquote, or vikalpa, of a sense of continuity of self. So I think that debate, in some ways, I think you're making Dharmakirti sound like this kind of point instance and so on that are much more disconnected. But really, here's the second part of my question. It sounds to me like when you said that the presence of flowing time is required for the sense of an enduring subject, if by enduring subject you mean subjectivity, it sounds to me like they're just the same thing. It's not like necessary for the sense of it is the sense of an enduring subject, right?
Yeah, you could say that.
So if it's, in other words, if self means subjectivity in the moment, which has retention and protension, if that's what we mean by self, then I think that's what the self is.
Yeah.
Right?
Yeah.
As opposed to, which is in it, but that requires an intentional structure.
Yes.
So if you don't have an intentional structure, and that then raises that question, like, what if you didn't have that
Okay,
Which
okay.
is what Villeneuve, I think his name was, what he, I forget the fellow whose paper you were citing at the beginning.
Oh, Velleman.
Yeah, so.
No, okay.
So, yeah, you know, like, so it seems to me like the intentional structure is still doing a lot of work.
Yeah, okay, so good. So here's, I think, where we're going to have an interesting difference between, say, the Husserlian analysis and the Buddhist one. So for Husserl, reflexivity and intentionality go together. You can never have one without the other. So the example is listening to a melody, so that's intentionality. And the hearing of the notes is through the retaining of the listening, that's the reflexivity. For Husserl, you can't have reflexivity without intentionality. And you can't have intentionality without reflexivity. Now, for the Yogacara thinkers, you tell me, because you're the expert, but they, at least as I understand them, say that the subject-object structure, if by intentionality we mean a subject-object structure, that is a non-conceptual distortion, and consciousness itself, absent that structure, is reflexivity. Now, Husserl does not do that, at least in the 1905 lectures. I'm going to leave later Husserl out because it's just way too complicated. But in those lectures, that's not the story. However, it seems to me that within the conceptual space of Husserl thinking, you could say to Husserl, look, is it possible to, lose the intentionality and to keep the reflexivity? And he could possibly say yes to that, but then he would say there's no world consciousness anymore. So, the Yogacara might be able to go along with that too and say, yeah, that's right, there's no world consciousness. And then what are you talking about? You're talking about whatever, Nirvikalpajana is, non-conceptual awareness. And that's a whole other kettle of fish. Merleau-Ponty is trying he's trying to have his cake and eat it too, as Bob would say. So he's trying to keep, his move is basically to say, it was a mistake to think that the world is there for you because of subject-object intentionality. That's what I did in phenomenology of perception, that's the mistake. No, the world is there, but it's there non-objectified. So he wants to retain a kind of world presence, but not with the subject-object structure. But it's not, I don't think, so I think it's more like Dogen, but it's not like, an absorption and a non-conceptual awareness in the, in the Yogacara vein, I don't think.
I'm going to ask a very stupid question that
those are always the ones that are I'm most afraid of.
I lose all your respect and the respect of a lot of people in this room completely, but I can't refrain from asking this. I come from a very different philosophical perspective. Please excuse this to me. You started wonderfully. This is somehow this relation between the time part and the sense part, and it's a wonderful thing. Then you go to Bergson, and I made all effort to understand Bergson. I just don't get it. I just don't get this sort of duration. I just don't get it. I don't know what it's talking about. Now, let me try to express where I'm confused very, very precisely, and go to my very super stupid question. Of course, a clock doesn't measure duration. It's not meant to measure duration. It's just meant to move. Okay? But my iPhone does measure duration. It has an app which says how long it says it's duration of something. Okay? I'm going to do a bit more than that. I have a sense of flowing time, of course, okay, which I believe is the one you're talking about when you know it. But I don't know if you have it, but I assume you have it, and I have. Now, you can say I have experienced a certain duration. My iPhone can say experience a certain duration, but that's not my question. I hear melody. My iPhone recognizes melodies. There's a little app that everybody knows is called Shazam, which recognizes melodies very, very nice. Why? Because there's something here which can perfectly well describe in terms of retention, in terms of Husserl term. Okay? Because it has memory. And in every precise moment, in the memory of the iPhone, in the physical structure of the iPhone, there's a memory of something happened before. Not only that, there's a memory of a memory. That's how we recognize melodies. And with a little bit more complicated application, there are all the other structures that you described. So now my question is, when you're talking about the subject of this, it's certainly, I sort of understand when the subject is Carlo, but I want to understand when the subject is Evan. So should I also include my iPhone?
Right. Okay,
and
yeah.
If not, there's nothing in what you've said that distinguishes for me even the iPhone. So either it's something else you're talking about, or what?
Okay,
You
great.
see where
Yeah, I got it. I think I got it. So this is the same question that keeps coming up, that has to do with sentience and consciousness, that Bob raised, that came up, Bob's response in relation to your talk. So I think I take it as a sign of progress that we're honing in on certain core issues. So I would say, no, your iPhone does not have memory, does not have duration. It does in looped through you, it does. But in itself, it does not. It is a sequence of states, it's a computational device, and it does not have anything like retentional memory. It does only through you. It doesn't record duration except through you.
How do I distinguish the iPhone from you? What allows me to distinguish? I mean, I know how
You need to answer that question.
No, I know how to distinguish the phone from myself because I have my own inside view, but I don't have your inside view, and I don't have the iPhone inside view. So
well, that's a different right. That's a different question. So
no, that's my question.
Right. Okay.
My question is not how to distinguish myself as a subject.
Right, but right, but your question was
you as a subject.
Okay. I just want to make a clarification. Your question was initially premised on your iPhone being durational. So I do not accept that. But your point was how do you tell the difference between your iPhone and me? So that is a question now that I want to address. So there's different ways to respond to a question like that. But I would say that there is always in place the human life world of intersubjectivity within which we create things like iPhones that have a different status from each other as sentient beings. Now, that can get changed and challenged through the development of artificial intelligence, but I don't think it has quite yet in the relevant way, though I admit that it could possibly be. So that's one point. Secondly, though, if we want to go deeper than that, this is a more fundamental point about the first-person perspective, the nature of the first-person perspective. So if you start from thinking that the first-person perspective is an inherently closed solipsist perspective, then you have to work out to what's the difference between, from the first-person perspective, another possible first-person perspective like me or the iPhone. Then you've already, I think, missed the first-person perspective being what it is in relationship to other first-person perspectives. That is, you miss the second-person perspective. The first-person perspective is always already a second-person perspective as well. So you can't close it in on itself that way. Sorry, say again?
I have a second-person relation with a tree.
Good,
so
good.
Good.
Yeah, it's open what the second-person perspective can be in relationship to. I'm just saying it's not really in relationship to an iPhone when we properly understand iPhones. Trees, rocks is maybe a little bit different, and future synthetic artificial and intelligent entities that are genuinely autonomous and autopoietic and all of that, that might be true too.
What I don't understand is a distinct, deep philosophical distinction between sentience and nonsense. That's I don't get.
It is that's bigger.
Thing, I mean, there are tall people and short people, so there are more sentient things and less sentient things.
Bob's dying to get in.
I just want, very quickly, there's an alternative way, I think, to make Evan's point in response to your question, which is to say you can't ultimately make a distinction between the iPhone and Evan. But you can make a distinction between yourself and the iPhone. Yeah. And that's all Evan needs. That's all he needs. I think
you could do it that way. You could do it that way. But, I mean, it's a bit solipsist for me, because...
Not if you weave that into the loop. Because the solipsism is true, but it's only at one point on the loop.
Right,
This isn't a guide.
Yeah. If you think of it more loopy and dialectically, then, okay.
Okay, I
yes, you should.
Yes, we move this to lunch. So thank you so much.
Thanks.
my pleasure to introduce Robert Sharp, our host and sponsor, and he's going to talk about on what physicists can learn from medieval Buddhist debates over the nature of
I'm actually really happy now because we didn't plan it this way, but my talk is covering much of the same ground that the early two talks today covered, but from a slightly different vantage point. So I think it's actually going to make it easier for me. So in convening a conversation among physicists, philosophers, is this too loud, by the way? No. Okay. Physicists, philosophers of science, and Buddhologists, there are two pitfalls that should be avoided. The first, I think, is more obvious. It's the tacit, if not explicit, claim made by some Buddhist authors that quantum mechanics provides scientific evidence for, or empirical proof of, what Buddhist sages discovered long ago. This sort of Buddhist triumphalism ends up doing an injustice to both science and Buddhism. The second, related claim is that Buddhism offers a cogent answer or solution to the conceptual quandaries that have perplexed quantum theorists for the past century. As is well known, many of the founders of quantum mechanics were transfixed by the way that their new science to challenge scientific naturalism. How the measurement problem, for example, seemed to undermine notions of objectivity and scientific realism. Believed it impossible to make sense of measurement or observation without reference to consciousness or mind, and turned to Asian thought in the belief that Asian systems rooted in an ancient inner science had a purchase on the nature of consciousness and its relation to the manifest world. Their Asian interlocutors did little to blunt their enthusiasm. Now, I believe this claim to be naive and uninformed. The crux of my presentation today is that Buddhism does indeed bring something to the table, but not in the form of problems like quantum measurement or the discord between manifest time and physical time. On the contrary, what makes Buddhist philosophers worthy of our attention is that they have been wrestling with many of the same conundrums. They too were trying to make sense of the interdependence of observer and observed, of relations without relata, and of how to reconcile eternalist theories of time with our experience of time's passage. Such conundrums lie at the heart of Buddhist doctrines such as dependent origination, two truths, emptiness, three natures, and so on. And in their struggles to unpack these postulates, Buddhist scholastics gave rise to multiple competing schools of thought: Madhyamika, Yogacara, Tiantai, Huayan, Zen, and so on. Now, even advocates of one and the same school found much to disagree about, and later doxographers would come to speak of prasangika versus svatantrika interpretations of Madhyamika, or on-mountain gradual schools of Zen, and so on. And even these neat labels mask the messiness on the ground. Such labels function much like Copenhagen or decoherence or Everettian do in quantum theory. Even those in the same camp often disagree on how their position is to be cashed out. So I was drawn to quantum mechanics out of a sense that the disparate Buddhist responses to the mind-world problem are structurally isomorphic to the competing interpretations of quantum mechanics in play today. Now, the claim that medieval Buddhists gave rise to the same range of interpretations found in quantum mechanics may seem far-fetched, particularly since Buddhists, with their key tenets of dependent origination and emptiness, are often presented as situated more on the anti-realist side of the metaphysical spectrum. And that should place Buddhism closer in spirit to psi-epistemic approaches such as Copenhagen or relational quantum mechanics and cubism. And this is indeed the path trodden in writings by Carlo Rovelli and Michel Bitbol, among others. But as I said, Buddhism is far from univocal on these issues. There are Buddhist analogues to psiontic interpretations in general, and to hidden variables, and even to many worlds in particular. And this, I submit, is itself an important data point. It speaks to the underlying structure of the puzzle these theories are attempting to solve. Moreover, Buddhists have been struggling with these issues for some 2 millennia, and in the process have established an impressive conceptual toolkit that merits our attention. Hence, my proposed third way to a dialogue between Buddhism and quantum mechanics would have us attend to what the Buddhists have to offer, while still avoiding the dual traps of using science to warrant Buddhism and Buddhism to fix the science. So my focus is on the underlying structure of the mind-world problem. The notion that mind and world are interdependent, that the object of cognition co-arises with a cognitive apparatus, has been a central tenet of Buddhism from as far back as we can go. As I mentioned, it gave rise to a host of competing interpretations, but we can divide them broadly into realist and anti-realist camps. And I know some of the Buddhologists here are going to squirm, but just go with me. The realists insist that it is intellectually fatuous to deny a mind-independent truth that accounts for the intersubjective coherence and law-like regularities, or karma, that we observe in the phenomenal domain. Right? This is somewhat akin to Putnam's argument that denying realism turns the success of science into a miracle. They feel that the entire Buddhist enterprise will collapse if such a reality is not affirmed. After all, the goal of Buddhism is to awaken from the illusion and to apprehend things as they really are, and that is to discern suchness, or the Dharma realm, or the body of truth, or Buddha matrix, right? Tatata, Dharma Dhatu, Dharmakaya, Tathagatagarbha, and so on. These terms, for the realists, designate something real. And then there are the anti-realists, who respond by arguing that this mind-independent truth, the view from nowhere, is not just an unobtainable ideal, but is incoherent from the get-go. There is no stepping outside. Absolute truth is the truth that all truth is relational, and this, they argue, is the real import of dependent origination. Hence, they would interpret terms like suchness, tatata, as simply designating the emptiness or relational character of all conditioned things. Right? And many would place Madhyamika here, but I would note that Madhyamika comes in both realist and anti-realist flavors. Right? People argue about that. So the Buddhists have had a couple thousand years head start in pondering the mind-world observer-observed conundrum, and in that time they produced an enormous literature on the topic. Nonetheless, and this is key to my argument, they have yet to make a logically consistent realist or anti-realist interpretation stick. To paraphrase Richard Feynman, I think I can safely say that nobody really understands dependent origination. Now, one clue that the goal eludes their grasp is that virtually all participants in the debates end up resorting to two rhetorical tricks, which I call the fission gambit and the fusion gambit. The fission gambit is the claim that something that appears to be singular is actually two, or dual, and the fusion gambit argues that something that is dual is actually singular. And these rhetorical ploys are needed for the simple reason that the realist and anti-realist positions turn out to be mutually entailing. And this makes contradiction and paradox unavoidable. This is something that Evan was talking about near the end of his talk. The interdependence of these two antithetical positions and the dialetheia that ensues is not merely analytic, it is existential. And I'm going over this very quickly because I've written on this before, but in a previous paper I put it this way. The paradox has its roots in the nature of what it is to be an embodied sentient being. I am, at one and the same time, both object and subject to myself. I am born into and occupy a tiny corner of the universe that surrounds and exceeds me on all sides. I apprehend myself as something existing within that universe. And yet the universe in which I find myself has no palpable being apart from its appearance to me, and this me is nowhere to be found within the empirical world. In a very real way, the realist claim that I emerge within the world, and the anti-realist claim that the world emerges within me, while contradictory, must both be true. And I refer to this as the loop. Now, drawing on Nagel, I trace the loop via notions of first versus third-person perspectives. The third-person perspective is the view from nowhere, a view that aspires to transcend all viewpoints. The first-person perspective is, to put it simply, how the world shows up for me here and now in the immediacy of my being. Taken to its logical extreme, it is how things appear bereft of conceptual or linguistic mediations, since such mediations necessarily involve the overlay of third-personal, socially shared resources. Now, whether a purely first-personal perspective or a purely third-personal perspective are possible or even intelligible is a matter of debate. But I do not believe it is germane to my immediate purposes, as my claim is that to be human is precisely to find oneself suspended, as it were, or navigating, or fumbling around in the space that is opened up between these two poles. Now, to an audience of physicists and philosophers, the idea of a third personal view from nowhere is clear enough, irrespective of what, if any, value you may want to assign to it. But the notion of first person is slippery, and it is here that I believe that many go awry. In conceiving of the first person, one has no recourse but to rely on third-personal resources. In conceiving of the first person, one has no recourse but to rely on third-personal resources, right? In Zen, this is what they mean when they say, already your mouth is open. The first person is then correlated with notions like subjectivity, experience, consciousness, awareness, agency, and so on. And this use of third-personal concepts to capture the first-person perspective explains in part the slippage from measurement causes collapse to consciousness causes collapse. I think this was the point that Chris was making in his talk yesterday. In making this move, one's first personhood is projected outwards into the world, and one finds oneself swimming in Cartesian waters with debates over qualia and the hard problem of consciousness and physicalism versus idealism and panpsychism and so on. Now note that the language of qualia, which is popular among philosophers of mind, is precisely an attempt to ascribe determinative, if not objective, qualities or characteristics or content to something whose salient quality is its unremitting for-me-ness. The first person is not located within the world, but is rather my opening to the world. The move to qualia or to consciousness flattens things out, turning myself, me, into a mere instance or specimen of something had by all. So by first personal, I mean precisely that, the view from right here. Kojève and Merleau-Ponty would seem to refer to this when they speak of the whole in being, and Heidegger refers to the clearing through which Dasein is disclosed. Sartre talks about nothingness that allows being for itself to withdraw into being in itself. Harding, who is perhaps the most relentless exponent of the first personal in the sense that I'm using it here, speaks of the aware space on top of his shoulders, which is where his head should be. In Zen, it's known as your original face, or sometimes even better, your original face before your parents were born. Now, all such expressions are valiant efforts to keep intentional content or qualia or even consciousness out of the picture. They're all gesturing to a perspective from which I do not emerge within the world, but rather the world emerges within me. And I think that, inspired by Zen readings of Madhyamika, as well as his Kantian leanings, this is what Michel Bitbol keeps emphasizing, as well, perhaps, as the authors of the blind spot argument, Adam, Frank, Evan, and Marcello. Oh, Adam, Frank, sorry, turned it into 4 authors there. Note, however, that despite one's best efforts, talk of a void or a clearing or the blind spot is inevitably third personal. And the moment one assumes this hole or clearing or void is a something that is possessed by everyone, it is projected back into the world, and the first person slips through one's fingers. There is a primordial and ineliminable asymmetry between me and everyone else. To see this, just ponder for a moment the profound difference between the death of someone else, anybody else, and your own death. Now, I don't have time to unpack this now, but I do hope the structural similarities with Wigner's friend is not lost on the audience. In other words, it's not that the quantum buck stops with measurement or observation or consciousness. From this perspective, the buck can only stop right here with me. And if your concern at this point is the specter of solipsism, I would remind you that the solipsist claim is that only the first-person perspective is true. My argument is that both first and third-person perspectives must be true, and while this generates paradox, we can't simply run from it, which is many people's first impulse. Rather, we must learn to work with it. Now, I hope that this long preamble will help as I move to the Buddhist understanding of time. The Buddhists struggled with the problem of time for centuries, producing a host of competing theories, but unsurprisingly, their positions fall into two broad camps, the presentists and the eternalists. The presentists believe that only the present moment is real, and our experience of time is simply the experience of moment-to-moment change or flux. This position is held by, among others, the Sautrantika, Dharmaguptaka, Theravada, and Yogacara traditions, who privilege, as do modern phenomenologists, the experiential now. To them, it is incoherent to speak about the existence of past and future things, or dharmas. You can think of them as atoms. Right? The past is simply what once existed. The future is what will exist. The past is what once existed, and the future is what will exist. Now, at first sight, the presentist approach seems to be a natural corollary to the Buddhist doctrines of impermanence, momentariness, and dependent origination. That is, the notion that mind and world, or observer and observed, co-arise in each moment. In this sense, it is reminiscent of versions of Copenhagen anti-realism insofar as a discrete particle with definitive eigenvalues only exists in a transitory correlation with an observer. The Buddhist presentist position, much like Bohr's, is actually difficult to get your mind around, as it looks like you get a determinate something out of nothing. And indeed, some of the critiques of presentism from within the Buddhist fold remind us of critiques that Einstein, Schrödinger, and Bell leveled against Copenhagen. Buddhists believe in karma, which is a kind of natural law of cause and effect. And Buddhist logic, as well as Buddhist scripture, demands that everything that appears in the present must be the effect of a prior cause. There is no place in either the material or mental domains for chance or randomness. But if all conditioned things emerge through causes, then those causes must exist. At the same time, according to some, a cause can't logically arise simultaneously with its effect, and so the cause of something happening now must lie in the past or future. Ergo, past and future exist. In short, without causality, the Buddhist project dies, and restricting the real to the present moment seems to render causality unintelligible. In response to this critique, the presentists come up with a number of theories. The most popular and enduring is the Sautrantika theory that the past leaves behind seeds, these are bija, that continue unseen into the present, and they remain there, underground as it were, until they can discharge their effect. The notion of seeds is revealing. It is a tacit admission that a strictly presentist metaphysics, one in which the universe is created anew in each moment, makes it difficult, if not impossible, to account for causality. The Buddhists had run directly into the Humean problem. If you privilege the phenomenological or first-person perspective, you have only the now, and that leaves you with contingency, but not necessity. To ensure necessity, the Sautrantika presentists had to appeal to an explanatory mechanism that lies outside the phenomenal flux. The causal seeds, to follow the botanical metaphor, are buried underground and thus known only through their effects. As such, they have the same rhetorical and logical function that hidden variables have in quantum mechanics. They are undetectable, but their existence must be assumed in order to vouchsafe causality. But ad hoc fixtures like seeds or hidden variables don't offer a solution to the problem so much as they foreground the problem's structure. In the popular imagination, Buddhist thought is associated with presentism. It comes, and actually many of the account you heard from Evan this morning was a presentist account. And this comes with, at least the popular notion that Buddhism is all about presentism, comes with the fashionable but I think confused idea that Buddhism is about mindfulness, and mindfulness means being in the moment, and being in the moment is cool since that's where reality is. But this may have been a minority position in Buddhist India. The dominant school throughout the golden age of Abhidharma scholasticism was Sarvastivada, a term that literally means the doctrine that all exists. According to the orthodox branch of the Sarvastivada, known as the Vaibhashika, all, when they say all exists, it means past things, present things, and future things. They're all real. And I should clarify, when Jay talked about it the other day, he was talking about a later notion of this. They're very careful to say not that the past exists, not that the future exists, but past things exist and past future exists. They don't have a conception of time. It's not a Newtonian sense of time as a kind of container. So the Vaibhashika masters hold that the causal regularities we perceive are unintelligible without assuming the eternal existence of past and future dharmas, for only then can they serve as the causes of present effects. Moreover, they argue that it is incoherent to postulate change or flux unless one grants a fixed or essential nature against which change and flux could be ascertained. As a result, they insist that all ultimately existing things, that's the dharmas, you can think of them as little quarks, they must have an unchanging essence, or svabhava, and this leads the Vaibhashika to a theory that bears some resemblance to contemporary block time theories. Everything that ever was or ever will be is real, and any particular event can be understood as determined by the configuration of the whole. However, the Vaibhashika's block is not static. There's a kind of wave-like ripple that moves through it, caused not by the arising and passing away of dharmas that comprise the block. They are eternal and fixed, but rather some modification of their state. And the nature of this modification was the subject of intense and ongoing controversy. Surviving texts, which we have primarily in medieval Chinese translations of lost Sanskrit originals, record 4 alternative Vaibhashika theories, along with variations on each. And I'm going to very quickly run through the next, what I'm going to run through is a bit of the Sarvastivadin theory, and don't worry about following it all. I just want to give you a sense, sort of like throwing a bunch of math up for philosophers. I just want to give you a sense of the intensity with which they were trying to figure this stuff out. There are 4 positions. There's Dharmatratra, who argues that a dharma, while eternal, undergoes a change in its state or mode, or its bhava. There's Goshaka, who argues that the change is that of the dharma's aspect or character, its lakshana. Vasumitra, who talks about the release of a dharma's potency, or its karitra. And Buddhadeva, who explains the appearance of change in terms of a shift in relative perspective. And actually, if you go into his theory, it reminds me a lot of Janan's recent work, trying to make sense of manifest time within a kind of physical time. Now, I don't have time to elucidate these complex and at times perplexing theories here, but the mature model is one offered by the 5th century CE scholar Sanghabhadra, and it's an amalgam of theories number 1 and 3. So in his synthesis, manifest time is the result of a cluster of dharmas altering their state and momentarily discharging their abiding function, or their energy, their karitra. And this constitutes the change from future to present. And this activity lasts just an instant, upon which the dharma goes through another state change, this time from present to past. The discharge is what creates the causal conditions for the activation of a new constellation of elements. But even when a dharma is inactive, in its past and future modalities, it can still serve as the object of a present mental cognition. And it does this by means of its capacity or its efficacy, samarthya, or power, or shakti, which is differentiated from its activity proper. So activity is associated with the homogeneous cause, the sambhaga hetu, which is the intrinsic causal ability of a dharma to reproduce or project itself from moment to moment within its own causal stream. Capacity is what allows a dharma potentially in the past or future to participate in a network of causal conditions that contribute to an activity of some other dharma. Okay, so I just wanted to give you, that's our version of math. So everything's position in the block remains fixed, but the individual elements undergo a kind of phase transition in which they momentarily enter into this complex network of relationships with other elements in the blocks. And these relationships always involve a correlation between a cognitive apparatus, minimally a sense faculty, and a sense consciousness, as well as a perceptual object. And this correlation accounts for our phenomenal sense of a now. Right? So think of different parts in this static block lighting up like neurons in a brain. So the manifest now that ripples through the block consists of dharmas or elements changing not their nature, but their mode of being. So the fundamental problem for the Vaibhashika then is how to make sense of the claim that a dharma, which Abhidharmikas is supposed to be unitary and indivisible, can have a fixed and eternal essence and yet still undergo change. This became a huge problem and leads to another thing which I'm just going to do really quickly. I say, in their efforts to explain this, they avail themselves of some esoteric exegetical resources, including the distinction between intrinsic characteristics and shared characteristics, between primary intrinsic characteristics and secondary intrinsic characteristics, and so on. So all that I really need for the purposes of my argument today is that the Vaibhashikas are trying to get their heads around causality. And in doing so, they feel compelled to posit a kind of block universe in which past, present, and future are all mind-independently real. But unlike some of the block theories proposed by physicists today, the Vaibhashika masters also felt compelled to account for manifest time, for our experience of time, for how things show up for us. And this leads them to incorporate a kind of spotlight theory that explains the appearance of the present in terms of a wave of phase transitions activated within the block. Okay. And how they avoid fatalism is an issue I'm not going to go into here, but we can talk about it later. So the Vaibhashika theory that all exists addresses one problem, the Humean problem, only to generate others. And their opponents, the Sautrantika presentists, as well as the Vaibhajyavadins, who held to a kind of evolving or open-ended block model, they were quick to pounce, and the debates went on for literally centuries. And their competing theoretical models became increasingly sophisticated and arcane. Okay, let's step back for a moment and take stock of the structure of the debate. We seem to be presented with two alternative approaches to the puzzle of time. One, the presentist approach, gives ontological priority to our experience of the now, to the phenomenological immediacy and givenness of our life world. Phenomenologists insist that all philosophical inquiry must begin here with one's immediate experience, since the world doesn't show up at all unless and until it shows up for someone. But from the vantage point of the immediacy of first-personal experience, past and future are rendered mere conceptual imputations, and hence time itself disappears. Right? We're left only with what William James calls the specious present. The second approach to time is the eternalist model, which gives epistemic and ontological priority to a third personal or realist perspective that aspires to understand what lies beyond the immediacy of our experience. And again, there's good reasons to support this position, as without it we are left describing but never explaining how and why things appear as they do. Curiously, from this objective or third personal vantage point, the now itself disappears, and without the now there is sequence but no movement, and we're left only with the timeless block. And this, of course, is what Ellis McTaggart deals with in his famous 1908 paper, The Unreality of Time. It's been talked about briefly before, in the conference, McTaggart introduces 3 ways of looking at time, which he calls the A series and the B series and the C series. And this schema has been widely adopted even by those who disagree with McTaggart's conclusions. In short, the B series arranges all positions in time in terms of their temporal relations to one another. Every position is either earlier or later than every other. McTaggart argues that the B series gives us fixed sequence but not time, as the relationships are static. In short, the B series gives us the block without change. For time proper, you need to designate events as belonging to the past, present, or future, for only then can there be a change from one state to another. And these past, present, and future constitute the A series. But given that events must be able to move through time, from farther in the future to closer in the future, or from future to present, for example, events must change their relationship not to other events, because the relations among events are static, but to something extrinsic to the series of events themselves. Thus, the A series presupposes an exogenous claim of reference against which one can determine the location in time of an event in the B series. So McTaggart then argues that if the designations past, present, and future must be either relational or qualities, right? If they're relational, then the meaning of past in the A series can only be established through an appeal to yet another A series, and you end up with a vicious circle or regress. If they are qualities, then every event must possess all 3, and one has to explain how any event can have them successively, which quickly lands one back in the same vicious loop. So as either the A series or B series gives us, or neither the A series nor the B series gives us time. And McTaggart concludes that time is unreal. Now, one simple way of making sense of McTaggart's argument, there's many different ways. Many people have had a go at McTaggart. But one simple way to do it is that empirically we only experience the specious present, the moment, the now. But this doesn't give us time per se, but only an eternal now. Even to claim that our subjective experience is in the present is question-begging. Like, where else could it be? So for time to exist objectively, we need past and future, but there's no way to peg the referent of past and future without indexing it to the now, and the now turns out to have no intelligible third personal or objective sense. So to borrow from Madhyamika, past, present, and future turn out to be mere conceptual imputations, empty of any objective reference. And this is somewhat the argument that Jay gave in his talk. Perhaps we can account for our apparent experience of time's passage by marrying a first-personal presentist now to the third-personal eternalist block, finding manifest time within physical time. And this is a popular project among philosophers of time today. Craig Callender and Janan Ishmael have both contributed to this area, and this is precisely what the Vaibhashika project was. They start with the realist claim that everything exists, as they believe this is the only way to make sense of causality, and they end up with a block, or the B series. To add time to the block, the A series, they take recourse in scholastic distinctions between existence and intrinsic existence, or between characteristic and substance, and so on. Distinctions that are intended to explain how an element that is singular and eternal can nonetheless alter its state. The task they have set themselves up for looks impossible because I believe the internalist and presentist positions are fundamentally antithetical. The only way forward would seem to be to adopt either one, a dialectical approach that takes recourse in multiple levels of truth, or two, a dialethic approach that is willing to acknowledge and countenance paradox, which is the Zen approach. But like all Abhidharmikas, the Vaibhashika masters are unwilling to do either, and so they punt, and they make ample use of the fission and fusion gambits. And we may find their sophisticated attempts to square the circle unconvincing, but they are instructive nonetheless. Note that the Vaibhashika following their understanding of Buddhist orthodoxy, cannot take recourse in a first-personal self, as their entire project is to show that the self is an illusion that can be explained through the mereological reduction of the manifest world into its underlying parts, the indivisible dharmas that give rise to the illusion. And McTaggart, too, cannot aver to the self, or the now, as his assumption, as I read him, is that the goal is an objective or rational account of time and rules out reference to the deictic now. Like proponents of psiontic theories, such as many worlds or superdeterminism, the point is to eliminate the metaphysical role of an observer, irrespective of the cost in terms of parsimony. Now let me try to bring the threads of my argument together. I've suggested that it is a mistake to conceptualize the first person in third-personal terms. That is, to imagine that there is some intrinsic property, be it experience or subjectivity or intentionality or agency, that makes me me. To put it another way, there is nothing in the content of my life world, my genetic endowment, my upbringing, my personality, my life experiences, that can account for why I am me. For if it were a matter of content, then I very well might be someone else. And having a personality, since having a personality or life experience and so on is something had by all. From a third-personal stance, this may seem to be an utterly wrong-headed or perverse or just plain silly argument. I can feel the Buddhologists in the room getting very nervous here. But I'd ask you to consider running the same argument in the case of time. There is nothing in the content of the now that makes the now now. For if content played a role, then any point in time could be now. Indeed, each and every point in the past and the future was or will be a now, and yet they are not now. Thus, that which makes the deictic now now cannot be dependent on anything having to do with content. That is, it can't be dependent on anything that is taking place in time. Right? This is a point that McTaggart actually makes in his Reductio on the A series. The now does not exist in time, or if you will, in the world. Rather, the now is the opening to time. It gives us time, just as the self is the opening to the world. Now, I'm drawing this argument in part from the Japanese philosopher Nagai Hitoshi, who drives home his point this way. He says, imagine an all-knowing God, or if you will, Laplace's demon, who knows absolutely everything about the world, including everyone's inner life and everything that has ever happened or will happen in all time. Right? It is the view from nowhere, God's eye view. Yet even this omniscient creature still wouldn't know two things that I know. It doesn't know that I am me, and it doesn't know that now is now. Right? And I was recently delighted to find Marcelo Gleiser making precisely the same point when he writes, if God is all-knowing, is omniscient, knows every atom, then God has no arrow and no flow of time. So we know something that God doesn't. And this raises the interesting question. Is the me that is the opening to the world and the now that is the opening to time one and the same thing? And this is something for another day. I admit I'm punting on that one. But one preliminary observation I would make is that it is impossible to disaggregate the two. You don't have the deictic now without the observing self, and vice versa. Now, I'm not by no means the first to note this relationship. As we saw this morning, David Vellman ponders the relationship between our sense of self and our sense of time's passage, both of which, following a Buddhist line of thought, he considers to be illusions. And Craig Callender has entertained the same idea as well. But Vellman and Callender's suggestion that these are illusions is motivated again by a desire to preserve scientific realism in general and physical time in particular. Craig, you can correct me if I'm wrong. The thought is that the deictic first-personal perspective, which gives us both the self and the now, is epiphenomenal and will eventually yield to a third-personal account. But my retort is that you don't get to help yourself to the third person, to the world out there, without the first person. So to conclude, I have suggested that the underlying problem of time, the paradoxical manner in which first and third person perspectives are antithetical and yet mutually dependent, is structurally the same problem as that of the observer in quantum mechanics. It is also the same problem the Buddhists wrestled with as they struggled to make sense of dependent origination. The manner in which subject and object, or grasper and grasped, are inextricably intertwined. I've also suggested that the problem is embedded existentially in what it is to be an embodied being, to be both a subject and object to ourselves. And finally, I have argued that we need to take special care as we incorporate the first person into the story we tell, as there is an almost irresistible tendency to render it in third-personal terms. And in doing so, we lose not only the observer, but also the observed. Thank you.
Thank you, because this was super useful for somebody like me, and really opening a new universe of things. So thank you very much. It's really, it's really useful, informative. If I may, you cheated a little bit because you started in a completely sort of geographical survey of point of view, but then you zoomed out to your, on a number of specific ideas and that kind of perspective. But this was very good and appreciated. I just want to make a very general comment on that, related not to the specific things in which you ended up, but to the general. Us about the variety of Eastern perspective and the region of Eastern perspective, and to keep well into account in relation to science. So, at this level, I want to make a point. Physicists are very pirates about philosophy. First of all, they have different nationalities and they work together without a problem, but not entirely. And that's the point. The situation, the reason why in physics there is it's also completely different from the reason for which these issues were debated in the past, whether by MacTaggart or by Kant or by Husserl or by St. Augustine or in which is a number of very specific discoveries of things that were known at some point and were not known before, that forced the physicists to some conclusion which challenged some particular philosophies that they were having. And the typical examples are, for what concerns time, there's a certain version of presentism that is just incompatible with a certain version, I don't say presentism, which is just incompatible with the fact that the two twins come back and one is older than one. Facts of nature. And as far as quantum mechanics is, I mean, if you want to be a certain kind of a realist of some way, in which what is real is accessible, is there, is not hidden, but it's determined and everything. So, what to mark this difference? It doesn't take away anything about what you say. We're not really in the same situation. We are discussing some extra problems in a sense.
Okay, so one way that I can immediately translate it into a kind of physicalist argument that I understand is some would argue, I mean, the move to the block universe was in part inspired by relativity and the fact that there can be no now. There can't be an objective now, right? And presentism, when you talk about presentism, I'm not endorsing presentism. When you talk about presentism, it takes the now and places it in the world in precisely the way that there are good arguments that physicists have made. I mean, there's good empirical facts that show that there can't be a kind of synchrony among multiple nows. But that's precisely why I want to hold on to a certain understanding of first personhood that emphasizes an asymmetry. So when I talk about now, I'm talking about me. I'm not talking about something that exists in the world. So I'm not sure that it is subject to the worry or concern that you have. I'm not saying that you would endorse it, making a certain kind of claim. But what I am saying is you can't make whatever your notion is unless you can accommodate this dramatic asymmetry between who you are and who everybody else is in the world. And I don't know what someone is supposed to do with it. I can just say, or the argument is, you can't go the way you're going because they've been working at it now for 2 millennia and they haven't made it work. And you've been working on it now in the quantum world for a good 100 years. And I would argue, when they take these famous votes at physicists' convention about which interpretation of quantum mechanics do you adhere to, and nobody gets more than, 20, 30, 40%. The fact that there's no consensus here, I think, has to do with the fact that people are desperately trying to avoid this kind of asymmetry, if my term asymmetry makes sense.
You mentioned how the need for causality in Buddhism in particular as being kind of a foundational principle pushes you towards having to give one or other account of time, which, as you mentioned, there's many different options. But I wanted to take a step back and ask if anyone had thought in that tradition of the possibility that causation might be a broadly synchronic phenomenon. So, for example, in contemporary metaphysics, there's views according to which causation really involves the mutual manifestation of dispositions or powers. And actually, interestingly, because this is physics, Buddhism, and philosophy, I just wanted to introduce people to Mary Shepard if they haven't heard about her. She was an incredible philosopher writing in 1824, 1827, 2 incredible tracts, where she advanced the view that causation involved mutual manifestation of powers. And this is very much in line with a necessitarian point of view, because you can't really get that wedge in between cause and effect. So I just wanted to ask you about that.
So there is, I don't know if my colleagues here know, there is a very detailed theory that some of the Vaibhashikas come up with, which does allow for a kind of simultaneous causality. But remember, they are sort of block theorists, so it no longer is quite clear. It's not necessarily simultaneity in the way we think of simultaneity. In other words, the past cause is effecting a present activity. And there's a kind of simultaneity because they both exist. It makes no sense to say they both exist now, but they both exist. And so they argue that that's a kind of simultaneity. I believe there's other theories as well, simultaneous causation, but they're not things that Jay may be familiar with.
Just a couple points. First of all, I thought that was an interesting point that Carlo brought up. That, science sort of will uncover different aspects through their experimentation that then, sort of previous philosophical ideas no longer become tenable. But it always seems like, sort of philosophy in the long history of human conception, almost all the alternatives have already been mapped out by somebody somewhere. This is like a point that Marcello made in his book about cosmology. That pretty much every human society has at least mapped out somewhere some possibility that we can include in scientific cosmology. We're never going to get, no matter any idea in scientific cosmology is already going to have an antecedent in somebody's myth. So the interesting thing is how physics sheds new light on that question, or forces to go back, perhaps to Madhyamaka, to say, maybe somebody has, articulated points that we can now use. And so I would want, here you bring up, it's true, this idea, this is always the fundamental problem, that asymmetry. I agree about that asymmetry. And for me, often when I read, the Buddhist literature, it's the idea that ultimately, what's going to happen is you're going to have non-dual. It's like, you want a story, right? Either you're going to get a description, the first-person view, or you want a story from the third-person view. But ultimately, you can have knowledge in the sense of experience, but the story, words fail. Words are only, they're just simply not going to be able to touch that ground. So I wonder, sort of, when you think about this, like what, Evan brought up the idea of a strange loop. Perhaps that's what we should be working on, sort of articulating, getting a better handle on what these strange
Yeah, I mean, I agree with that. I think that it's the loopiness is really unavoidable. And of course, people do run from it because I do believe, Jay and I, two others, just wrote a book on paradox in which we try to argue that you really can't deal with some deep existential questions without being willing to embrace at times when it becomes important, contradiction and paradox. If you constantly run from it, you're just not getting there.
My question, actually building off this question of the loop, trying to understand how the loop might work. Maybe the question is how to work the loop. So for me, it seems like perhaps to move from one pole to another, we drop out of propositional content and into activity. And so to describe that movement is to not do it. But the way in which you're going to move, the way in which you're going to sort of accomplish the benefit of flipping perspectives is actually sort of propositional. It's sort of inactive, it's participatory, it's sort of in the activity. Wondering how that tracks with.
So, I'm really a specialist in Chan and Zen, and I have done my best not to mention Chan and Zen in this talk, but really that's my thing, and what I'm actually presenting is a very Zen-y way to look at this. And in some things that I've done recently, I can give you references later, I actually show it's exactly that, how the Zen people try to work with this. In other words, they don't run from it, but they work with it and try to get you, is sort of make you more disposed to take seriously the loopiness of the situation that we're in. That's what the koan literature is about. A lot of people think that koan literature is meant to kind of sidestep into activity. That's just bad reading. That's just being illiterate in the genre. That in its day, it was a way of dealing seriously with the paradoxes that were absolutely fundamental in Buddhist metaphysics, in Buddhist thought, Buddhist philosophy. So I can give you references.
I couldn't resist the opportunity for a shout out that I know that you already know about. But this issue and the embrace of this paradox is also old in Western philosophy, and it's Schopenhauer, to whom we want to turn for that. And the world of will and representation, he opens the text by saying there's this enormous paradox that until the first eye opens, there's no world. But there has to have been a world for eons before the first eye can open. And refers to that as the paradox of the belt knot, right? The knot of the world. And quite explicitly says it's an irreconcilable paradox. But he gives us a way of thinking about the loop as well. Because he argues that one direction of dependency is transcendental and one is empirical. And that the empirical is necessary in order to explain why it's possible to have a transcendental condition. And the transcendental condition is necessary in order to explain the empirical. So you don't escape the loop, you don't escape the paradox, but you get a nice way of thinking about the way they are together. And that's why more people should read Schopenhauer.
Just a quick question, which is, I'm just, this is not a problem for Dharmakirti, or in any of the commentarial literature. Like, they don't use, they talk about seeds in certain other contexts of memory, but they don't use seeds to explain causality. This is an issue. So I'm just wondering, like, did they not get it, or?
Well,
was their presence is.
So, in other words, let me step back a bit and see if I understand what you're saying. I am making a claim that no Buddhists have been able to make this stuff stick. In other words, that they always end up. You're saying, no, you can make a clean go at Dharmakirti, no contradiction, but.
Maybe it's slightly different. What I'm saying is they thought it wasn't a problem. I'm not saying they got it right.
Oh, I see.
I'm just saying that in the tradition, there's no sign like,
But
they didn't take the Sarvastivada position seriously, basically.
Oh, no, no, of course. They're trying to make it go at different ways. Where I would say the problem comes up with Dharmakirti is when you have to use something like a sliding scale to make sense of him. Then I think that, to me, is a little tip-off. We're in the loop, And we're trying not to make it loopy, dialectical. We're going to say, no, we have to parameterize his statements and understand it as layered the paradox way. So to me, and this is just my own disposition, when I see moves like that, like it's sliding scale or a kind of gradual approach, that to me is a tip-off that you're actually in the loop, but you don't want to acknowledge it.
Well, it's my pleasure to introduce the speaker of our second talk of the afternoon. This is Craig Callender, and he will be speaking on the flowing self.
My talk will connect with a variety of the other talks. What I'm going to try to do is give a picture of why we think that flows. And so it's very much in the spirit that Hugh Price mentioned when he mentioned the kind of Ramseyan pragmatic move where you're sort of looking at why do critters go around saying the things they do? And so I try to give an explanation of that. I don't know anything about Buddhism, so many of the speakers have said that, but for me it's really, really true. And also I'm going to give a talk, because I know that we've got Buddhist scholars, philosophers, and physicists, and so I'm sort of aiming at the lowest common denominator, but if in the Q&A I'm happy to go into the weeds as much as you like. Okay, and then I have a second Buddhist theme, again, not knowing anything about Buddhism. And this is something that I've been just playing around with in the last, it struck me 2 weeks ago. I'm very curious to see what people think about it. It's okay if you laugh at it. Or okay. So physics attributes to space, time, or space-time and particular structures. You need these structures to do the physics. You'll find them immersed in the laws of physics. And so they might be things like spatial distance, duration, spatial temporal distance, order, chirality, dimensionality. Maybe it's discrete, maybe it's continuous. There's all of those sorts of features. And you need those to do physics. I mean, in the physical theory, you need those. But to actually use physics, or just get around in life, you need also pragmatics, and in particular deixis, which is the Greek for pointing. Deixis refers to the interpretation of an expression depending on its context of production. And so here you think about all the kind of indexicals like here, now, then, right, left, all sorts of things that, for their meaning rely on where you are. Deic center, which is, in time would be the now, in space it might be the here, or right or left, things like that. You can also think about, the self and I. Now, McTaggart in 1908, made this important distinction. It also comes up in cognitive linguistics that, again, it's called Deic centers. But where this distinction between B properties and A properties. So B properties are, well, he's talking about time, and so they were thinking about duration and order, and these are then, they're sort of always true. So whether, the U.S. Civil War was before World War II, that was true before it happened, after it happened, that's true while it happened. On the other hand, then there are, there's the A properties, and again, with time, we've been talking about the now, where, at some point you would think, well, it's not now the Civil War. So you've got this distinction. Now, what's funny is that in ordinary life, we objectify the temporal deic structure and not the spatial deic structure. And so we endow these structures, and we endow these structures with special features. So when we look here, we've got, we don't think of, right and left as objective. It's always relative to me and my perspective. But we do think that this is the now. This is what's really happening in the now. So why do we? So we treat space and time differently this way. Interestingly, this sort of shows, when people talk about relativity spatializing time, but all it really does, it doesn't spatialize time because it makes huge differences. It makes big claims about differences between the space-like and the time-like directions. It's just that relativity doesn't objectify the dyadic structure, the dyadic temporal structure, but then neither did classical mechanics. Newtonian mechanics didn't tell you when the now was. So we have these creatures, us. It's really important to us, this kind of temporal dyadic structure. In my book, I talk about, Jim Harville has this, IGESs, information gathering utilizing systems. The features of IGESs won't matter, so we'll just call it IGES Iggy. And so we have Iggy, and Iggy walks around as she's living life with this kind of model of time in her head, and it shows up in all of her thought, language, behavior. And it's this model where you've got this special now. It's like, you don't really, the ordinary person in the street doesn't think about how far the now extends or anything, but it sees things in the past. And then you have the now is updating itself in some way. And then you have a past, and you don't just have a past, but you think of the past as immutable. It's done, it's over and done, it's fixed. And then you think of the future as open. And so you're attributing all these properties to things that are dependent on this dyadic structure. And that affects really the way we live our lives. So we have Iggy is in a relativistic space-time whose main structure is just the Lycombe structure. People talk about the relativity of simultaneity and all this. Relativity doesn't talk about simultaneity at all. They just don't need it. And so it's just not positive. And so you just don't, so Iggy's just, as she's looking around in the relativistic space-time, she's not going to find this structure that's so important to her life. And so people complain, in science, they say, I forget who I was quoting, the equations make sense, but they don't satisfy those who ask why we perceive it now, or why time seems to flow the way it does. And I think this was an interview with Lee Smolin. This was the reporter speaking of. This cold-blooded mathematical formulation doesn't do justice to the experience we all have of being in time. So you've got a kind of problem that's like the Eddington problem of the, Eddington talks about the two tables, the kind of manifest table and then the physical table, and there's this big gap between the two in terms of, the one is hard, the other one's mostly filled with air, etc. Similarly, you have one here between manifest time and physical time. So how do I get this out of there if that's the way I'm going to go, or could I go the other way, which is a little bit more the way Evan was going. Yeah, so one response is that physical time is inaccurate or incomplete. Maybe you can bring metaphysics into the rescue. And so here there come all the presentists and becomingists and eternalists, they're all coming in, and there's 1,000 different types. There's Meinungian, skipping, jumping, thick and thin presentism, and just hundreds of types of presentism. The American Journal of, the Australasian Journal of Philosophy put out an alert about 10 years ago saying we have so many papers to referee on presentism, we can't keep up. The demand is not meeting, the supply of reviewers is not meeting the demand because there's so many papers. Well, does it rescue it? Well, in my book, I say, in various publications, I say the rescue is a bit like this, rescue of the cat. Where, the thing is, these rescues don't work in any way. So they don't explain in any way why you get manifest time. Why? Because if we look, all these theories are defined by what exists when. But existence is the perfect, so on a Frege-Russell view, it's not even a property, but if you take a view where you think of existence as a property, it doesn't have any features, right? That's the point of the property of existence. So it doesn't smell, it doesn't have mass, it doesn't taste anything. And so therefore, they're always explanatorily infinite, these theories, in terms of explaining why a creature like me would have the kind of experiences I do. And so I don't really look to see, I don't look to find the answer in any of those. So then the other response that you see often mentioned in physics is manifest time is an illusion. And I don't think it's really an illusion, strictly speaking, if you look at what the word illusion means and look at the theory later. But, so I have this kind of, so in my book I have this kind of approach where, so there's this awesome debate between the philosopher Adolf Grubham and Feynman, who's going by Dr. Mr. X, and when these discussions got published. And Feynman says, in theory, one should be able to create this feeling of madness in a sufficiently elaborate machine. And the physicist Thomas Gold said, we ought to eliminate this flow idea from the real picture of the world, but before we can eliminate it, we ought to understand how it arises. We should understand that there can be self-consistent sets of rules that would give a beast this kind of phony picture of time. And that's what I want to do, is to give the rules by which this beast comes up with this phony conception of time. So that's what I do in my book. First half of the book is on physics, second half, cognosci. And so in my approach, I look at all the sort of genuine differences between the space-like and the time-like directions in a relativistic world, look at the kind of environment that Iggy is in, the kind of challenges she faces, have her as an embedded subject in this world, and then imagine what evolution will do, and then pop out why creatures like us would model the world with the way we do. And so I can't go through that whole thing, but I'll just give you a little sort of snippet, a little flavor, a taste. Well, there are different places to begin. I struggled with where to begin, but I ended up beginning with the construction of the subjective present, and just thinking about how it is we construct this. Because the present is sort of the beginning of this manifest time picture, right? If I don't have the present, then I don't have something updating, I don't have the difference between the past and the future, so I thought I'd begin there. And even there, I could have began at different places. But I began with this construction of the present. And it's something we don't really think about that much, but your brain is doing a hell of a lot of work trying to construct these sort of experiential moments that we call presents. So I'm thinking of stuff that's not fallen into memory yet, and not anticipation, but what you think of as your immediate experience. And there's just a heck of a lot going on. So the creature is really challenged with this really hard problem. You're trying to go around in the world, navigate the world, and you've got all these signals bombarding you. The signals come at different speeds. They come from different events or the same event. They don't have any kind of little sign on them that says, hey, they're not like the mail. When the mail comes, there's a date stamp on it. There's no time stamps on any of this stuff. And so you get all these signals coming, and then it's your job to then figure out, what is happening, now. And it's a matter of life or death, because if you don't think that the audio signal from a tiger roaring is coming from the same event as the visual signal of the tiger right in front of you, you might die anyway because the tiger that close and you didn't hear it. But still, it helps to bind those things together. And so you can think about, a creature is trying to sort this out. You can think of it as a kind of common cause game where there's certain utilities in the environment of trying to, making the wrong guess, thinking the two signals came from the same event or not. So you get some gain, you get some cost. So there's predators and there's preys, and you're now trying to optimize this and come up with a kind of simultaneity window such that you'll get you'll live. And so we're all doing that to some extent, but of course evolution is doing that on the long time scale. It's probably doing that differently for different creatures. So if you think about, if you were to try to tap your nose and tap your feet at the same time, at what point would those two tappings be simultaneous? the feet are much further away from the brain than the nose, and so does the distance from your brain matter? What about for a giraffe? A giraffe has it's like 9 feet to the head, back to the hoofs. If it's binding together and it's now the hoofs going a certain way, well then, it might be that the giraffe has not only a long neck but a long nap, because the window is probably a little bit bigger. Anyway, without going into all the details, I thought, well, one example gives you the flavor, and I'll come back to it. So I always knew there should be such a case, and then I was really happy when there was. So if there's something, I figured if there's something we do, then it should also break. And so there's this subject known as PH, who's a retired, I don't know how old he is right now, but he was 67 when the study was done. He was a retired pilot in England, and he had some kind of small lesion on his brain. He was fine. He was cognitively very highly functioning, but he was recuperating in his daughter's house, and she came home from work, and all the televisions were apart. And he said that the audio and visual were out of whack. And then she started speaking, and he heard her, then sees the mouth move. And he has a point of subjective simultaneity of 210 milliseconds. So he's a sound firster. So sound is very slow, but the ears are very fast. Light is very fast, but the eye is very slow. And so people put it differently. So some people are sound firsters, light firsters. He's a sound firster, and he's tilted 210 milliseconds. Now that's definitely conscious, right? So if you think, the way I would think about that is that's halfway of a baseball to the pitcher's mound is about 210 or so. And so it's definitely conscious. Now, so he seems like he's an outlier. But then what's interesting is the people who did the study looked at other people, and about 1/3 of whom in the lab were able to consciously notice the difference between the audio and visual things at sometimes approaching that level. It's just that in ordinary life, you don't really notice that. It's like if I snap my finger, then everyone would say, that snap came from him moving his fingers. But now some of you probably actually heard it when the finger was like here, when you saw it here. The actual noise comes when the finger hits the back part of the thumb. But, there might be, and then there might be people who are sitting there on the thumb a little bit. But of course, you'd be laughed at if you thought that noise didn't come from this. So in ordinary life, you don't really have much. There are other things, so there's like the feeling of agency could have begun there. There's a lot going on in this momentary present. Anyway, so there's a whole bunch of stuff going on here. Janan calls them TEMPs, and I always screw up what the TEMP stands for. Temporally embedded momentary presence. You don't remember. It's something like that. It's basically your subjective present. And all the stuff that's going on in there. So, Iggy and her friends, they all have these. It's interesting to think about a world where now I also have pH, and it turns out we're like pH, but we just don't notice it so much. And so, in fact, all the studies I know of that measure point of subjective simultaneity, turns out to be statistically significant differences between every individual in the study. And so we're all going around in our own little clocks, our own little presence. It's just that, so in pH we'll say, this is the now. It's just that as Bob was just saying, the content, but the thing is, the content of his now is not going to be the same as the content of our now. Because he's not putting in the the movement of the lips with the hello, whereas the rest of us are. But really, we're all like him, is the point. But somehow we manage to get along. Oh, and we end up thinking that the world has this special present. Well, why do we do this? Well, one nice point that the philosopher Christoph Hurl makes that I hadn't thought of before was that, the experience, it seems perspectiveless when it comes to time. So when I'm thinking of the spatial dyadic structure, I would always say, thinking that the spatial dyadic structure is objective is a theory that doesn't make it to dinner, because you immediately say, that's pass the salt on your left, right? So you're immediately recognizing that there's another perspective. Again, spatially, I can see a little bit of my nose when I talk, so you're coming from a particular perspective. But with time, there's not anything like that. And also, since you don't meet too many PHs as you're bouncing around in the world, it then leads you to then think that it's objective. And so you have, as Hurl says, an invitation to project. So I'm projecting this kind of experience that I have onto the world. And so it's sort of the opposite way of what some people were suggesting. And then there's all these reasons to have intersubjective agreement. So you can think of, you can look at the different sorts of, you can just think about evolution and all sorts of other reasons why you have a lot of intersubjective agreement. And so all of this leads to thinking that the temporal dyadic structure is objective, where you don't have that same corresponding argument for the spatial dyadic structure. But now, why does Iggy think she moves up her world line? Let me just see what. Okay. So she'll say things like, New Year's is coming up, and things like that. And she'll talk about time flowing, and she believes she's flowing up the world line, or maybe the world line's flowing down to her. Why does this happen? Well, here is the first Buddhist theme, and when you teach elementary, logic or reasoning, you're taught to never make an argument by authority. But here's an argument by authority. If a continental philosopher and an analytic philosopher and Buddhist philosophers and science fiction authors all agree, if all four groups agree, then there's something to it. And so here you see Merleau-Ponty say, time presupposes a view of time, is therefore not like a river, not a flowing substance. The fact that the metaphor based on this comparison has persisted from the time of Heraclitus to our own day is explained by our surreptitiously putting into the river a witness of its course. And then you can see the same sorts of things in Ursula Le Guin and Buddha via Villemin. And so on Villemin's view, what's going on is you have so you have this idea of a conventional self in Buddhism, and here the idea is that the flow of time is a result of that convention. So it too is a conventional thing. It's not there in the world itself. And so Villemin says, so the idea is you think to yourself that you're an enduring thing, but you're really not. And having this self-conception of yourself as an enduring thing, it makes you think that you are the self-same entity again and again and again. And so the world changes, but you don't. It's always still you. This enduring, changeless substance in a way. I won't read the quote. And how do you then get from that to the idea that time is dynamic? Well, then I use some stuff from cognitive linguistics to show how that happens. And I'm the sort of philosopher of science who thinks that philosophy is often useful or best, really, when you can sort of try to tease all these philosophical themes into something where they become scientific, where you could then hand it off to science. And so if you think of the history of philosophy, it's been we spun off, Aristotle spun off biology, and spin off all these, Turing spun off computer science. And so think of trying to get things so that they can become scientific. in cognitive linguistics, I talk about these kind of schemas, cognitive schemas that you have. The moving ego versus a time-moving schema. There are other variations, but they're kind of along the same lines. So if I said to you, so you've got a meeting next Wednesday. So I said to you, next Wednesday's meeting is going to move forward 2 days. Right now, how many people think it's Friday? How many people Monday? More Mondayers. So there's no right answer. But it'd be good if there's a right answer, because some people would be showing up at the right time. But so you have these different sorts of schemas that you use. So there's this ego-moving one, where you're sort of moving up the timeline, and a lot of language on that. So I'm coming up upon Christmas versus Christmas is coming upon me. So you have these two. There's all these studies where you'll switch back and forth between the two of them without even knowing it in a conversation. And they do really evil experiments where they show up at O'Hare Airport, grab the most jet-lagged people that can fly from long-haul flights, and then start asking them questions, and then they switch the cognitive frame in the middle and see how much cognitive load this puts on them. Test who said this. Oh, the highlight part isn't there. It's McTaggart. So McTaggart says, so he's talking about the flow of time, but is that movement from past to future or from future to past? So the father of the time flow doesn't know what direction it flows in. It's because he's talking about this very thing, I think. Anyway, so in the book, I try to come up with ways in which you could try to test this in some way. Think about, so you could get really there are all these different conceptions of the self. There are all sorts of different abilities that we have, so we can develop kind of stuff called autobiographical memory. So that doesn't happen, we're not just born with that, it comes to us later. We have the ability to do temporal decentering, which is where I can sort of move myself. I can move my dyadic self along on a timeline. Really little kids can't do this, so I can think of that when I was 8 years old, and when that was, so the mid-70s was the now, then I was still yet to play my first basketball game. And so I could say that was in the future then, and do that kind of manipulation. Anyway, I won't go into the details there. Okay, so final thing. Bob Hemme talked about all that. Final thing is the second Buddhist theme. Well, so, we all know there's this no self view, and then it's often said that it should lessen the fear of death. So if you have the no self view, that other self, the later ones, they're not you really. There is no enduring you. And so somehow this is supposed to make you feel better about dying. And then I was struck by, often I'll do interviews in magazines or something like this, and I was thinking about the Buddhist thing, and then I was thinking, I often get asked, so many times I get asked, if you believe in the block universe, does that make you feel better about dying? And, it's a no. Not one bit. But you can sort of see the idea, you're like in heaven, so there are times at which you're not, but you're still on the block, and so you're like in heaven or something, because there's this moment. So anyway, it's interesting that you have this. This isn't the point I want to get to, really, but this is just sort of why I came up with the thing. Why what struck me on the next slide is struck me. I mean, you could ask, then, should the metaphysics justify the attitude? It doesn't change the attitude. This is Jay's wonderful paper with my friend Sean on looking at Buddhists and whether it does change their attitude about it. The answer is no. Anyway, but it made me, it sort of reminded, I thought about this paper by my friend Natalia Deng. So she has this, basically a logic paper, and she's pursuing this idea that I had a long time ago, which is that really presentism and internalism are the same. They're just two ways of saying the same thing. And so in logic, one is saying pastness operator, there were, dinosaurs, there were dinosaurs. The other one says, before this moment, there were dinosaurs. You can translate those two back and forth without loss. And so what really is at stake between the two? One is just, in terms of the logic, one is just using a restricted universal quantifier restricted to a particular time slice, and the other one's not. So you can switch back and forth, though. Anyway, so she goes through all these ways to try to figure out what the difference is between presentism and internalism. And at the end, she throws up her hands and says, fuck it, I can't. then she throws off this idea, which I thought was so awesome, really, but she doesn't really make anything of it. It's just sort of at the end of the paper as a kind of throwaway. And she said, well, why don't we, maybe we should reinterpret the internalism-presentism debate as normative, not as about metaphysics. So presentism and internalism are not descriptions of time, but guides to how to live it. And whether anyone else likes this or not, I kind of like this. So on this view, then presentism turns into only present events should play a role in a person's emotional and mental life. Internalism then says, is a kind of injunction to have similar attitudes toward an event, no matter whether it's past, present, or future. And so then I thought, well, if we think of, I put Buddhist star because I knew there's tons of Buddhists who are better interpreted as eternalists, but then I thought Buddha versus Buddha would not be as pithy as Buddha versus Spinoza. So Spinoza said, the mind, insofar as it's rational, should direct itself to past, present, and future equally. Both views are interesting because they're both revisionary, and so they both would recommend eliminating the emotional asymmetry of time. So neither would recommend, thinking about past headaches differently than future headaches. And so they're both very interesting. Again, not all are presentists. The second Buddha certainly was not, because he saw the block, according to legend. So he would definitely not have been a presentist. Anyway, I then thought, well, is there a way we can connect this to research in psychology? So there's all this work in psychology that where you have this kind of assumption that people differ in their perceptions of the past, present, and future, and that this becomes a kind of stable disposition. And so you can think of these people who are sort of out of balance with their temporal perspective. And so you can think of different sorts of people. So Smith is stuck in the past. He almost made it into pro baseball, but he didn't. He thinks about it constantly and lets it define him, and it affects his current decisions. Or say Lily, my daughter there. She's constantly going to parties at UC Berkeley. She should be working on her Byzantine art history project on a Tunisian baptismal font. Or think of Sang. Sang is stuck in the future. He works 80+ hours a week at Samsung, sometimes sleeping there, neglecting friends and relaxation. So you can see if there are these sort of ways of being sort of fixed on temporal perspective in a way that maybe is unhealthy. The most famous way of thinking about this is this Zimbardo time perspective inventory. There's my scores there. The balanced one is there. You'll see I'm extremely unbalanced if you look at the scores. There's a lot of criticism of that. But there are many other kind of constructs, and there's a lot of ongoing work on trying to come up with good constructs that are reliable and valid and in general. As I mentioned, too, to give you a kind of idea. So temporal metacognition is the ability to consciously self-regulate the focus on the past, present, or future. So there'll be different measures of that. You can then look at those measures and correlate them with different measures of happiness and all sorts of other things. Temporal focus. I like these two because they have something where it's about where you have some element of control. So you have some control of your attention, but maybe not total control. So the attention individuals devote to thinking about the past, present, or future. And so you can look at these sorts of things, see if they really are stable dispositions of humans. So there's all the issues about personality traits, whether they are or not. These are kind of similar to that. And then there are many results that suggest that people with higher temporal metacognitive abilities are happier in life. And so I thought this would be an interesting way to sort of panel demetaphysized the eternalism presentism debate into something that would then be interesting to study. Okay, so that's it. I just wanted to end. Bob yesterday asked, how are you using Buddhism? Because we didn't want to use it like before. And so, first case, I'm using Buddhist conception of the self and developing a kind of cognitive error theory about flow. So I'm not suggesting that there's the solution to the interpretation of quantum mechanics or something there. And then second case, I'm not even suggesting, I'm wondering if it's useful to interpret some of the wisdom from Buddhist tradition as not about metaphysics of time, but about how to live in it, and whether we can connect that to recent research. Thank you.
Well, I think she's at Columbia now, and she's going to talk about a participatory universe in the realist mode.
So first, I just want to thank Bob and Sanjit and the organizers for this. For me, it's been like amazingly enriching. There's so many sort of. At first, I was going to start with a little preamble about what I thought this might have to do with Buddhism, but now I think that there's so many resonant threads that I'm just going to sort of dive in. What I'm going to do is I'm going to talk about a understanding, a way of understanding what quantum mechanics is teaching us. And then instead of trying to say anything much about Buddhism, I'm going to suggest that it at least affirms some of the threads in that tradition. I think some of the talks, most of the talks, will highlight for you or bring those into focus the kinds of things that I have in mind. I'm also going to apologize for speaking really fast. I really want to have time for questions and comments. What I'm going to be suggesting is a different way of seeing the difference between classical and quantum mechanics. So the fact that we can act in the world that we represent makes it impossible to stabilize certain features of the world as objects of knowledge. I'm going to explain what I mean by that. I'm going to call this phenomenon interference. Word's a little confusing in this. If you're thinking of quantum interference, just banish that for now and think of interference as a name for the phenomenon that I'm going to be talking about. I'm going to give some examples, distinguish it from disturbance and from ignorance, and then say how interference suggests that how interference propagates depends on the way that our actions are connected in the domain that we're representing. In the classical setting, interference is channeled and focused into the future. In the quantum setting, I'm going to suggest that interference is endemic. And what I'm going to suggest is that this casts light on the sense in which the universe is participatory and explore ways of understanding this in the realist mode. Most day-to-day physics, one is modeling other systems, so cells, gases. We maintain this provisional separation of subject and object, or investigator and system being investigated. Cosmology studies the universe, so it doesn't maintain that separation. It's customary in cosmology, maintained in the imaginative fiction that we're sitting outside the universe, looking down at it. And that can create problems that make it impossible to stabilize certain facts or features of the world as objects of knowledge, appropriate targets for the epistemic attitude. So the idea is that they want to program a system with a bunch of general knowledge and the ability to model the world. And they're coming up against the fact that some of what the system, some of what happens is stuff that the computer or this general intelligence does, and that creates a kind of interference. So let me give you a simple example. Suppose you want to program a computer to serve as our grand overarching database for the universe. So you give it a lot of factual information. It's going to be our depository of factual information about the world. We begin with the laws of physics and all of the scientific knowledge we've amassed. We add facts of history, what we know about the monkeys of Costa Rica and the vast regions of space. The goal is to be able to build enough knowledge into this thing that we can put to it any question of physical fact, and the answer is going to appear on an output channel. It's not hard to find a question that this kind of a system can't answer truthfully. You just ask it, is the answer to the question that's about to be displayed on the output channel? No. You think it through, you'll see that any answer it gives is going to be false. If it answers yes, clearly it's wrong. And since that misdescribes what it wrote, and if it answers no, it's wrong as well. So this might seem like an anomaly. Paradoxes of self-reference are well known to scientists and to philosophers. The problem is that when what the program does in this case, in giving the answer, interacts with what it says, rendering it false. So if the word no appearing on my screen at time t is going to affect the truth values of other propositions, right? So for example, other computers in the room are going to record my answer. A person who walks into the room will see it. Someone will take a picture. The electricity on the screen is going to change. The lint in the air, all of these things will be affected by what appears on the screen. And they will in their turn affect other things. The effects are going to ripple through the network of truths. The reason that the problem arises is that by saying things, the computer is doing things. And that creates interference between what it says and what it does. Logical paradox in this setting is a form of negative interference. What the computer says conflicts semantically with what it does. Nothing mysterious here. What is happening is that the computer can't stabilize the fact that it's trying to describe the answer to the question, right? The word that appears on the screen, independently of giving the answer. And the thing is set up so that no matter what answer it gives, it's going to be false. Okay? What it does in giving the answer conflicts with what it says. Negative interference can arise in less direct ways. So a boy tries to guess his Christmas present. Every day from June to December, he approaches with a new guest. Unbeknownst to him, his mother hasn't bought the thing yet. She's waiting until Christmas Eve to make the purchase, and she's determined to surprise him. You can see what's happening there. Again, the same sort of negative interference. The act of asking the question is going to interfere negatively with what happens. Poll predictions prompt responses that counter the predicted event. So predictions of Republican victory prompt Democratic turnout. Predictions prompt people to change their votes to make strategic guesses, given where other votes are falling, that reconfigure the whole field. So this phenomenon of interference is well known. Interference is different from ignorance and disturbance. In the case of ignorance, there is a fact well defined independently of our know the fact. In case of disturbance, there is some fact there to be known. So for example, you turn on a light to check whether or not your kids are asleep. The act of turning on the light wakes them up. In that case, there is a fact there to be known whether your kids were asleep before you turned on the light. Perfectly well-defined matter of fact, but the act of trying to ascertain it, the fact to be known in the case of interference. So think about the kid in the Christmas present, or the computer asking the question. The fact to be known is connected to our knowledge of it in a way that makes it impossible to stabilize independently. And I'm going to put that by saying there isn't a fact there to be known, or there isn't a fact there anyway or already. Okay. To understand what's going on in these mundane examples with the boy and his Christmas present, the fact to be known again is connected to his questioning in a way that makes it impossible to stabilize independently of his attempt. Okay. It just doesn't work. The logic of knowledge, in a way, presupposes that the object of knowledge is there to be known, or again, there already, or there anyway. They're independent of the act of trying to know it. And in those cases, one can't treat the features of the landscape that depend on one's own activity as potential objects of knowledge, for the same reason that the boy can't treat the Christmas present as a potential object of knowledge. Wasn't hard to find examples of interference. I just gave you a couple in a classical setting. Genuinely problematic in some domains. So the boy and his Christmas present, that was artificial and it was arranged. But stock predictions and election polls, right? Any case where one's predictions become public and then feed back into and affect the domain being described, alter the course of events being predicted, in those cases you really can't stabilize what you are representing independently of the act of representing it. Knowledge is possible in a classical setting because interference in that setting is controlled and it's disciplined. Everyday perceptual interactions, so if you see something in front of you, those are unaffected by interference. Those exchanges have the logic, I'm going to say, the logic of measurement. I interact with an object. My state after the interaction is correlated with its state before the interaction, and so I've acquired some information about the state of the object before the interaction. A little bit different when we look at the future. Philosophers tend to picture knowledge as a kind of relation between a transcendent subject and eternal truths. It's not. Knowledge is embodied and it's efficacious. So it's the whole point from an evolutionary perspective. The whole point of knowledge from an evolutionary perspective is to guide action. Present knowledge guides action, making it impossible for an embodied agent to stabilize her own future to the extent to which it's guided by knowledge as an object of knowledge. Anything that you can predict, you can act to forestall, avoid, deter. This is just the internal version of the pollsters and the election outcome. Right? Predictions feeding back into the domain and affecting the outcome that they describe. Agency is the enemy of knowledge in this sense. We saw above that when we were talking about the computer, that is the computer that was supposed to be the grand depository of all truth, from the point of view of knowledge, we wanted to minimize the disturbances that the computer's own activity had on the domain it was representing. From the point of view of agency, however, we want to use knowledge to guide action, making knowledge as active and as efficacious as possible. Present knowledge guides behavior, acting on its own predictions, and making it impossible for that reason to stabilize the future as something that's there to be known, there already, or there anyway. Trying to stabilize the future for an embodied agent as an object of knowledge is like chasing your own shadow, or like the child trying to guess its Christmas present. In that way, and for that reason, the future for us is not there to be known. So the kind of instability that I'm talking about isn't mysterious. Right? It doesn't threaten objectivity or realism. It doesn't even have to do with truth. The objective facts are the objective facts. What is true is what is true. It's just that our knowledge and our knowledge gathering activity is connected in the world. As I said, present knowledge guides, interferes with, so by guiding action, interferes with future fact and makes it impossible to treat the future as something that is, again, there to be known. A feature, not a bug. That's what agency is. It's using present knowledge to affect future fact. The agent manipulating the effects of her actions and using her knowledge to avoid, forestall, and so on, things that she doesn't want, and to promote, encourage ones that she does, is effectively exploiting the interference effects caused by her own knowledge. This isn't simply an epistemic fact. Our world is constituted in part by knowing agents acting in ways that depend on their knowledge, simply because the world includes us. What we can and cannot stabilize as objects of knowledge depends on the way that our own actions are connected in the domain of fact. So in a classical world, I said, we can take an epistemic attitude to the spatial environment and by extension to the past, but any attempt to stabilize beliefs about the future will encounter interference. What we find in a quantum world is that interference is endemic. The theory itself tells us. So, for example, in the famous double slit experiment, whether we see wave-like or particle-like behavior famously depends on whether we place particle detectors at the slits to observe position. Quantum system that we might try to use to get information about the system, that is, any of those much studied interactions that we call measurements in quantum mechanics, the statistics of which are predicted by Born's rule, those interfere with the properties of the system. The difficulty has always been in quantum mechanics to understand what things could be like in the quantum world in a way that explains the empirical predictions of quantum mechanics. And the logic that we bring to attempts to understand those interactions are the ones that are appropriate only if there is no interference. Interference in the specific sense that I said, if we can stabilize the objects independently of the attempt to try to know them. So, for example, what do we suppose? We assume that that unmeasured quantities have values. You saw this come up again and again in the other talks. We assume that if we perform a measurement and we obtain a result, the result reveals what was there before, or there anyway, or there already. We assume that if we can predict with certainty that the result of a measurement, this is something that Chris put pressure on, that if we can predict with certainty that the result of a measurement on a quantity A has the value X, then we can infer that that value has that quantity independently of the measurement. We assume, that is to say, that the properties that we observe when we do a measurement was there anyways. The logic of quantum mechanics, the logic built into the computational architecture of quantum mechanics, again for the reasons that Chris pointed out so nicely, just doesn't support any of these inferences. It doesn't allow us to treat the result of quantum measurements as revealing something that was there already or there anyway. The lesson of the last century of research in quantum foundations is that Schrödinger evolution does not allow us to produce the Born statistics if we hang on to the idea that these interactions are revealing antecedently existing categorical properties of measured systems. The history of no-go results from Gleason through Cauchy-Becker through Bell shows you that you can derive contradictions from Born statistics and the assumptions that measurements reveal those kinds of properties. And there's a history of interpretations that either modify the dynamics or relax aspects of the there already or there anywayness to try to accommodate the statistics. But this isn't an entirely unfamiliar phenomenon. We cannot stabilize properties of quantum systems as objects of knowledge in the same way and for the same reason that the child can't stabilize the Christmas present as an object of knowledge. There simply is not something there to be known for us independently of what we might try to find out about it. Quantum mechanics reveals that the stability of the world is only apparent, that the structures that are needed to stabilize the world in general as something that's there to be known. Indeed, the structures that are needed to stabilize ourselves as knowers, the structures that are needed to stabilize a conception of ourselves as I's and the world as an it, those are present only in an effective and emergent way. Doesn't mean that there is no world, only that the world is not, again, there to be known for us in a way that lets us stabilize its properties in the way that we can in a classical world, independently of our attempts to try to know it. How is this helpful? Right? Isn't this just telling us stuff that we already knew? I think it is in the following sense. It gives us a way of seeing the difference between the classical and quantum mechanics, classical world and quantum world, that demystifies some of the weirdness of quantum mechanics. The phenomenon of interference is incontestable. Any system that acts in the domain that it's representing is going to encounter interference. It arises in a classical setting as well, for the reasons that I said. Right? And it's easy to understand with the mundane examples, like the child and his Christmas present, or the computer and its attempt to answer the question. The difference between the quantum and the classical worlds is not that there's interference in one case and not in the other, but in how pervasive interference is. It also focuses us, I think, on the phenomenon of interference, and it foregrounds the fact that the conditions that allow knowledge in the traditional sense, the realization of the world as a potential object of knowledge, the separation of the subject's own activity and the things it's trying to find out, so stabilization of the world as a potential object of knowledge, those are special, those conditions. They're not generic. They don't always hold. So I titled my talk, A Participatory Universe in the Realist Mode, because I see what I'm saying as aligned with Wheeler's idea of observer participancy. So this is a nice diagram from one of Wheeler's famous papers. We use the idea of observer participancy to describe what he called elementary quantum phenomena. And his insight in introducing the phrase observer participancy that is hyphenated as a single word, not two words, was, I think, that observer participancy is the basic phenomenon. It's the general case. The ability to separate observation from participation, so to stabilize the world as something that can be known and seen, and with it, observers in the sense of emergent structures that interact with their environment in ways that obey the logic of observation. Okay, that's the special case. So we see this sort of diagram all the time, you know, when people are talking about agents. Right? As it's represented on the left, where the agent is separate and action. And of course, the agent will then be acting in the environment. The environment that it is representing will unavoidably create interference, just as we saw with the computer and its attempt to answer the question. And because its knowledge guides how it acts, what the agent can stabilize as an object of knowledge and what it can take a purely epistemic attitude towards, treat as there to be known, right, will depend on how its actions are, as I said, connected in the world that it's acting in. The difference between the quantum and the classical case is, again, not that one is participatory and the other is not. It's that in a classical world, interference caused by one's own actions is focused and channeled into the future. The spatial environment and the past are unaffected by interference. In the quantum world, again, it's endemic. What should one's attitude be in cases where interference is present? And again, you'll see connections with Chris's talk. Well, we know, sorry, let me ask that again. What should one's attitude be in cases where interference is present? That of the participant, not that of the observer. We know both attitudes because we live the perspective of the participant in our daily lives. It's not the logic of measurement, it's the logic of choice. Think about what a choice is. A choice produces an action that, in the specific sense I'm talking about, interferes with what happens. I make my choices strategic, exploiting the effects of interference. So, for example, I plant a crop in the fall, but if I want a crop in the fall, I plant seeds in the spring. If I want protection when the rain comes, I fix my roof. If I want my pasta overcooked, I leave it in too long. The mistake that the boy makes in his questioning of his mother is that he treats the present as an object of knowledge. In that capacity, his failure is guaranteed. If he treats it as a game of strategy, he can use it to get what he wants. Our attitude towards the quantum world has to be something, I'm suggesting, like our attitude to the future in a classical setting. Quantum measurements should be reconceived as quantum choices, the results of quantum choices. So you think about the logic of measurement. Measurements are characterized by the absence of interference. There's a suite of counterfactuals that are supposed to capture the idea that the results of a measurement reveal facts or properties that were there anyway, or there already. We assume, again, that the values of unobserved events, the values of observed or measured events obtain even if no measurement is performed. And even if a different measurement is performed, we assume that unmeasured quantities have values. If we obtain a result, that result would have obtained even if we hadn't performed the measurement. And that if we can measure A and we can measure B, we assume that the values we get for A and B are jointly compatible. Right? What about the logic of choice? We don't expect any of those counterfactuals to hold in the case of choice. In cases where the action, the result of the interaction is connected to what we choose, we don't expect it to be there already or there anyway, independent of the choice. We expect what happens to be tied to what we choose so that it doesn't happen whether or not we make the choice. We don't expect the results of of different possible choices to be compatible with one another. Ordinarily, we would understand all of this, everything that I've said, in causal terms, and against the background of a certain conception of time. So we imagine pre-theoretically that we live in a universe that's unfolding in time, that causal relations run from past to future, and that's why we think that we regard the past as fixed and the future as open. And that explains, we think pre-theoretically, why we take an epistemic attitude towards the past, treat it as something that's there to be known, and instead a strategic attitude towards the future. And then we bring these ideas about causation and time into a quantum setting, and it doesn't work. We don't know how to impose these ideas of time and causation onto the phenomena that we see in a quantum setting. I'm asking you to keep these ideas of causation and time out of your minds. Our everyday ideas about causation and time grew up in a classical setting, where they're natural in that setting as expressions of facts about the way that interference propagates in a classical world. If we look at the physics itself, the facts about how interference propagates in a classical world are explained by deeper physics that makes no mention of causation, and that post-relativity specifically rejects that conception of time. So the explanatory direction goes from facts about the way that interference propagates in a classical world, in a classical setting, to the ideas about time and causation that build those into a kind of metaphysical picture that frames our everyday ways of thinking. Post-relativistic classical physics is the universe is a four-dimensional manifold of events with no global conception of time. There's no unfolding. The laws don't incorporate any intrinsic direction of determination. The reason that interference propagates into the future has to do with facts that have been studied in the foundations of thermodynamics. It's a long physical story here, but what I want you to do is just suspend your everyday ideas about time and causation and try to understand things in terms of how interference propagates in these two different settings. It's convenient, if you like, to sort of imagine that you could, virtual worlds where you get to set the rules and say how things are connected and then explore what it would be like in different kinds of setting to activate one of the nodes and see how it propagates through the network. That's the kind of abstract way of thinking that I'm suggesting. Interference might better be called influence, what it can see itself as influencing by the actions that it makes. But again, I put it in this foreign vocabulary so that we don't impose our ordinary everyday causal ideas on it in trying to understand it. Okay, so Wheeler was also someone that made the suggestion that quantum measurements should be reconceived as choices. And he emphasized as well the participatory character of our interactions with the quantum world. Some of you may know, I thought Chris might talk about this, but he didn't, so let me tell you, for those of you who don't, Wheeler has this analogy of the game of 20 questions that he used to illustrate the difference between the classical and the quantum world. So in the ordinary version of this sort of parlor game, one person, the contestant, is left outside the room, while the others, the players, agree on some object. The contestant is then allowed back into the room, and he puts questions to the players that they have to answer truthfully. And the contestant wins if he guesses the object in 20 questions. Wheeler suggested a different version of the game, called it negative 20 questions. In this game, the players, unbeknownst to the contestant, don't actually agree on an object in advance. Whoever is asked a question by the contestant when they're let back into a room gets to invent an answer. They get to answer as they like, so long as their answer is compatible with all of the answers to the questions that have already been given. And then the last player gets to decide whether the game is won or lost. The difference between these two games is that in the first game, the questioner can take it, the questions, I should say, have an epistemic character. The answers that one gets in the original version of the game, reflect some antecedently determined or antecedently agreed upon fact. In the second, the object is being sculpted jointly by the questioner and the responses of the players in real time as the game unfolds. And this is what Wheeler says about it. The world, we once believed, exists out there, independently of any act of observation, just as I, thinking of himself now as the player, entering, thought the room contained a definite word. In actuality, the word, I called it an object, but the agreed upon object, or the word that describes it, was developed step by step through the questions that I asked, as the information about the electron is brought into being by the experiment that the experimenter chooses to make. That is, he said, had I asked different questions, or the same questions in a different order, I would have ended up with a different word. The experimenter would have ended with a different story for the doings of the electron. It's frustratingly hard to figure out what Wheeler himself, inspiration from Wheeler, have gone in the direction of cubism. So the talk that Chris gave is a beautiful articulation of the attitude that most of the people that have followed Wheeler in the Foundation's literature have gone. They've seen their world, their view, as a radical departure from classical conceptions of physics. Their view is defined in opposition to realist views that treat the wave function, so the mathematical object that represents the quantum state, views that think of that as describing an objective world. So according to cubism, the wave function is a user's manual for an agent, a tool that can be used to guide expectations of future experience on the basis of the past. I don't think this is about realism. It's about knowledge. It tells us that the quantum world isn't there already, or there anyways, for embedded observers, not because there is no world or no objective world, but because there is no observation in the classical sense. Every interaction is participatory. Even in a classical world, we're participants. And we can't treat the world as a whole as there already or there anyway for the reasons that I said, simply because it includes us. Some of what happens is stuff that we do. In the most basic sense, we can't describe the world as a whole as there anyway, since we're part of it. That basic self-referential kind of interference affects other parts of the landscape as well. But because of the way interference is channeled in a classical world, there are large parts of the world that we can stabilize independently of our own activity and treat as objects of knowledge. Perceptual interactions with the spatial environment have the logic of measurement, as I said. But because the spatial environment contains information about the past, both of those things, the past and the spatial environment, we can treat as a fixed background against which our actions occur. And then interference against that background runs into the future. Quantum mechanics tells us that our world, insofar as it's quantum, is more pervasively participatory than we thought. It tells us that our interactions with the quantum world have the character of the Buddha's attempts to figure out what his Christmas present is. It tells us that we should approach our interactions with the quantum world in a way the boy, if he understood what was really going on, should approach his guesses about the Christmas present, or in a way that the dealer's version of 20 questions should approach his play, namely strategically, not with an epistemic attitude. But to see how all of this can be accommodated in an objective ontology, I'm going to describe how it works in an Everettian setting, simply because that's the simplest and the most kind of objective. And it gives us some indication of how it might be treated in other objective ontologies. So I'm going to go back now to say a little bit that's going to connect to some other things. There's a discussion in the sort of, for those of you who know these names in philosophical literature, the Evan-Strawson tradition in analytic philosophy, roots in Kant, that talks about how the mind stabilizes a conception of self and world, flux of experience. Different waves coming out of this tradition. And there's also a tradition in analytic philosophy that talks about this, about how the self becomes stabilized as a subject or knower at the same time that the world becomes stabilized as an object. It talks about how experience becomes conceived as a relationship between subject and object, and experience is interpreted as a view of a world from the perspective of a body moving through space. Mars' simple theory of perception is sometimes used where the idea is that you start with visual experience, and the mind factorizes changes in experience, so changes in the array of colors. It factors changes in experience into changes in the world and changes in one's position in the world. The computation is one that minimizes change along both dimensions, imposing order on what would otherwise be just a Blumen-Bazin confusion. So this kind of story is an epistemological or logical story about how experience becomes articulated with any physical theory. That story has to be paired with an ontological story that starts with whatever the theory treats as ontological and shows how subjects arise and experience gets recovered, the kind of experience that subjects have gets recovered in a world by the theory that we have. In Everettian quantum mechanics, function is the basic object. Decoherence provides a physical mechanism for the suppression of quantum interference that tells us how the sort of branching structure of internally classical branching structure here, each of those sort of lines following that are outlined in blue represents a possible world history, an actual world history. And quantum mechanics tells us how this branching structure of internally classical-looking worlds arises. It's in the context of these classical worlds, that is, the histories that form this branching structure, that observers arise, and that the world becomes stabilized as a potential object of knowledge, as something that's there to be known, independently of the attempts to know it. So the account of how the classical world emerges from the quantum one is effectively an account of how a space is opened up for information-consuming agents that accumulate knowledge and use it to guide behavior. Quantum mechanics tells us how those conditions arise by telling us how the classical regime, and hence the sight of knowers and of an objective world that can be known, is stabilized out of the quantum world. It also tells us why attempts by classically to stabilize quantum systems as objects of knowledge. So you get an understanding of how a conception of self and world is stabilized out of experience, and an understanding of how a classical world that supports the emergence of information-consuming systems arises from a more fundamental ontology. There's a worry that's plagued participatory accounts of the about the role of observers. So the idea is, if observers bring the properties of electrons into being, what brings them into being, and so on. I think the worry is less severe in this setting. In an Everettian setting, observers emerge as inhabitants of the universe as decoherence stabilizes classical world histories. They arise only as emergent structures. So I said that quantum measurements should be reconceived as quantum choices. It's not an accident that I think accounts of quantum mechanics that treat measurements in a quantum way, so that bring these interactions, measurement interactions, under the quantum dynamics, treat it implicitly as having the logic of choice. This is also true, I think, on relational quantum mechanics, so I'll be interested to hear what Carlo thinks here. And one can regard, I think, the relational view in many ways as kind of dual to the Everettian one. The structures are largely the same. It depends on what takes as sort of real. In an Everettian setting, what we are choosing when we choose to make a measurement, so choose whether to check the cat, choose what to, in a delayed choice experiment, choose whether to measure position at the slits, to place detectors at the slits. What we're choosing is whether to decohere the wave function. And what measurement we choose would decohere it into different branches. So just like in the Wheelerian game, we're sculpting by what's going to be by the questions that we ask. So I've gone this long without even mentioning Buddhism because I'm really hesitant to talk about things that are so far out of my lane. I'm aware how complex their tradition is, and been even more impressed over the last few days with how shallow my knowledge is. So I thought I had a lot to say at the top of the Dunning-Kruger curve, and now I'm right about there. So what I'm going to do instead is what I said. I'm offering this as a vision of what quantum mechanics might be telling us that affirms some of the threads in that tradition. So if you look at quantum mechanics through these lenses, makes us aware that this needs to be in place for articulation, experience into subject and object, and the stabilization of the world as something that's a potential object of knowledge. Those conditions are not generic and emergent way. You see, if you look at quantum mechanics through these lenses, you see the dissolution of those structures at deeper levels. Quantum mechanics reveals a substructure to our everyday reality that belies the impression of stability, the illusion of separateness from the world. There's a breakdown of self as I and world as it. So all of the structure that supports these distinctions disappears at the fundamental level and reappears or emerges only with decoherence. Okay, so I'm going to stop there. Just a quick conclusion. Basic idea. Interference arises naturally and inevitably for any system that's part of the world, part of the domain that it's representing, becomes interesting in a connected domain where it will propagate along determined connections. Aspects of the world that are tied to their own actions can be stabilized as potential objects of knowledge insofar as their knowledge and its actions. In the classical setting, interference effects are channeled into the future. In a quantum setting, interference is endemic.
Wow, what a beautiful talk. Just
That was fascinating. I just had a question about the claim that, you know, the quantum world, for the reasons that you so nicely articulated, is not there to be known. And the extent to which the truth of that claim builds in a certain way of knowing, right, such that it must proceed by way of some kind of measurement or interaction, and that if we were to relax that particular kind of scientific way of thinking about, I think, given this endemic feature. So, for example, when I was thinking about the double slit experiment, yeah, we know we can perform the measurement, we can put the detectors at the slits. Oh, I must use it. Okay. So we can't put the detectors at the slits without, you know, undercutting or, you know, trying to find out. So let's not do that. Let's just observe what happens when we don't do that, which we can do. And then we perform something like an inference to the best explanation to the effect that something quantum-esque is going on there. It's not properly described as the particles going through one or the other slit. It's something else. It's a weird state. Then the question becomes, what can we say about that from, you know, the quantum perspective or metaphysical perspective? That's something I'm interested in trying to do. But, you know, the idea that there might be some kind of perhaps partial instantiation of each of the determinate values or some other kind of state which somehow encodes possibilities in such a way that nonetheless could be given a realistic construal. So just wondering if I think you see what I'm suggesting.
Yeah, I do. So specifically restricted to, you know, our ways of knowing that involve interactions, where the interactions themselves are understood in a quantum way.
Yeah.
So absolutely doesn't generalize beyond that.
Please, let me formulate the question this way. There is a lot I follow you in everything you say, and a lot I fully agree with. But there's a point in which I think I lose you, and I want to see what you think about that. What is the point I mean? I very much follow you when you say, look, there is this phenomenon of interference. And just because of this phenomenon of interference exists, we learn that we have to give up a certain sort of full representation way of understanding. Fantastic. So we give it up. Okay. So now you don't have to argue more to convince me that this step has to be taken. We take this step. I give this and then you also say that actually quantum mechanics make this thing that you call interference in your sense quite odd, quite more general. And I'm fully with you, yes. It's the same kind of in some sense, but it's much more wide. So now where do you disagree with you? Well, I don't follow you anymore when you sort of hang on to the original point for the following reason. If I am an astrophysicist today, and I use quantum mechanics, okay, I'm not a philosopher, I'm not a Buddhist, I am I go to baseball players and I do my astrophysics, I'm a good astrophysicist. What I think is that out there in the universe, a certain very well precise number of light years from now, there is a supernova where there is real stuff going on, a supernova explosion. So I know that there is an atom of hydrogen coming in, and this hydrogen atom coming in is hitting against an atom that we make a story of helium there, and depending on what the helium is reacting one way or the other. But it's quantum mechanics. So that atom of helium is acting with is neither in one state nor in another. Okay, I'm a quantum physicist, so I don't know how to know the computation. This is a superposition of the two. I use collapse, I use one interpretation of the other. But an interaction between the proton, the electron there hitting something which was quantum mechanical in a superposition.
Good.
So where I'm not following you is why you hang on to this.
Yeah, so I don't. I'm completely with you that these are entirely normal interaction. I mean, the world is fundamentally quantum, and every interaction is participatory. The reason I said this is about knowledge is because what the Born statistics are the products of a particular kind of interaction that, when modeled quantum mechanically, gets up if you understand that interaction as participatory. So I want to say the world is fundamentally quantum. The interactions that you've described, when we're not there, are quantum interactions. We only get confused when we try to understand the statistics that we observe in a way that forgets about the participatoriness. So I think we're in agreement. So that's why I said that knowledge is the special case. What we should try to understand is how in the classical world we get this emergent, non-participatory relationship with the spatial environment.
That was a lovely thought, the laying out of the logic, the two different kinds of logic that occur, the logic of measurement versus the logic of choice, I think, is how quantum mechanics forced us, right, to add, just like sort of Chris's point, forced to build this very nice this logic that could lead to cubism, but then you overlay some, well, I could also use this other thing, right? And the interesting thing to me is that logic that you laid out was so clear and so beautiful that now the next step becomes a choice, right? Well, and the other then is I'll say, no, but I really want to keep that, that realist view, and then you end up having to force yourself into a very weird story.
So I actually want to hang on to both perspectives. I see them as, to use a contested, I see them as dual to one another. They're two sides of the same coin. So that's why I said that there's a story that one tells about how one starts with experience and works one's way out. And there also has to be a story within any objective conception of the world in the context of a physical theory, for example, which I take to be a nicely regimented, articulated, fully objective conception of the world that includes us and has to say how observers arise. And I think that one shouldn't give priority to either of those, that each includes the other, and the right thing to do is to get them to fit together. So I think of this as radically anti-foundationalist. It's entirely internal story, internal to experience and internal to the world. The two include one another.
I just one last thing. I think that's a really interesting thing to pursue, right? But it also, I think your view is very much kind of blind spotting when we talk about. I don't mean blind spot negatively. Yeah. I mean positively in the sense that from our perspective, you always have to include us in the story. Now, maybe what you do with that, but for us, what we mean by we raise the issue of the blind spot, because what we want to point to is the fact that not doing that, being anti-foundationalist means you just can't take yourself out of the story. Now, maybe that you want to put that other level in, try and find a way to have that also the account of how you got there in the first place. That may be more.
So it's always hard for me to carve off some little piece that I can say clearly, So that's why I restricted it in the way that I did. But I'm going to say something impressionistic now. That's more than anything a kind of promissory note about how. But I think the right way to articulate all of this, I started by talking about negative interference, and that suggests blind spottiness, right? The right way if there can be negative interference, there can be positive interference. The only way not to get paradox is to let action lead belief follow. Right? You believe what you do. You don't form beliefs in advance. You get to act. Yeah. So I don't think of it as a blind spot at all. That's assured knowledge. There's no way for you to be wrong about, if you're the computer, there's no way for you to be wrong about what's going to appear if the questions you ask are, what am I going to say? Right? What am I going to do? So in a way, I think of this as not blind spottiness. That's why I said agency is the enemy of knowledge, right? Because for the purposes of knowledge, you want to minimize the disturbances, right? But you should let agency lead and belief follow, and you're not going to go wrong. You only go wrong when you treat parts of the world, as there to be known. If you treat them strategically and you let your beliefs be formed on the basis of what you do, you're going to be fine. So I think in a way that this is a way of opening up the space for agency that treats it seriously, that being precedes knowing. That's the wrong picture completely. There's no blind spot. That's the most assured sort. That's the part of the world we really know.
I was absolutely seduced by the talk.
Yeah.
Until I had a heart attack. When I saw that you misspelled.
Oh no, what did I write?
Capital Q, capital B.
Oh no, I'm so sorry.
And then I was seduced again until I had the next heart attack. And that's when you changed what I thought was a wonderful development, and then you took an agent within those branches, making a choice to accumulate one set of worlds versus the other. What the heck means choice in a deterministic universe, like of the Everettian sort?
Okay, so I've thought a lot about, I have a book on determinism and freedom. So for me, I mean, I have something to say about that, but it takes a book. Yeah.
Okay, well, let's thank Janine again. It's Marcelo Reiser. He's from Dartmouth University. And I don't know how many of you guys know this, but I learned at that banquet one night that he is a winner of the John Templeton Award. So not only is he a good speaker, but he's a very rich man. And probably the richest person in the room.
So thanks, Bob, for organizing this whole thing. Thanks all of you for surviving until 5:30, actually 5:45 now. So I'm going to do something very different. I'm not going to solve the problems of time or the interpretation of quantum mechanics. I just want to give sort of an overview of some of the ideas that have been floating around in the room. I mean, I didn't know they were going to float around, but sort of they are here, they're present, and see where we go from there. The first one is, I think there is a point in common between Buddhism, physics, and philosophy, which I hope nobody would argue with me about, which is that these are all attempts to figure out the perplexity of being human, in different ways, right? So we're all trying to make sense of existence in some way, and we do it from different perspectives. And I think here we have a chance of have this confluence of possible ways of knowing, and maybe learn from one another, which is a wonderful thing. So to that point, I would say that different cultures across time have been looking at the perplexity of being human in different ways, and they have came up with different explanations or ideas or dreams or theories about what it means to be human in a complicated universe where we have the awareness of being time-limited creatures, so to speak, right? And one thing that we've talked about, and Jay was one person that mentioned this, and I'd like to mention it again, is really the same question can be looked at in many, many different ways. And those ways kind of enrich each other, right? And so I always like to think of a glass of wine. Somebody talked about the daffodil, right? Was it you? Somebody who was you? Yes, the daffodil. And those things, you can look at a glass of wine, and if you're a biochemist, you're going to be interested in the fermentation of grapes and how sugar is going to turn into alcohol. If you're a physicist, you're going to be interested in the diffraction of light and the crystal structure of the glass you're drinking with. And if you're interested in the aroma of the wine, you're going to kind of, have the bouquet of this wine. And if you're really good at it, you can even try to guess, where this comes from and what's the vintage, etc. And then, of course, there's this other component of the glass of wine, which is who am I drinking the wine with? And all these perspectives are important for figuring out as a human being what it means to have a glass of wine in our hands. And I think we should never forget that, right? Now, speaking of that, Einstein, who was very much a realist, did say something like this, which I think is very important, which is, what I see in nature is a magnificent structure that we can comprehend only very imperfectly. And that must fill a thinking person with a feeling of humility, right? And coming from him, I think it's a wonderful statement of what it means to be a scientist, to construct a worldview through a scientific lens. And then, of course, there's the question of reality, right? And I love this picture because, you know, I think at least when I looked at it for the first time, my first reaction was, thank God I'm not the fish, you know? I mean, poor fish, right? I mean, he's right there, right? He can see there is a world out there that he can jump into and be free, but he can't. And so, good photographer, you know, we are the photographers. We can go to the beach and we can circulate around, and yes, you know, we're free to dive and swim, and yet we are just like the fish, because precisely for the same reason, Jenan used this example very nice. We are within the world we're trying to explain. Just like the fish, if you ask the fish, what is the ocean? You know, as we know, this is a story that has been told many times. It will be very hard for the fish to give a global explanation of what the ocean is from the perspective of being in the water. Right? And that is, in a sense, the question of reality for many of us. Now, I'm a great fan of this French philosopher from the late 17th century, Bernard Le Bovier de Fontenelle, who wrote a book, which is a spectacular book. If you have not read this book, you should absolutely read this book. It's called A Conversation on the Plurality of Worlds. 1686, about the same year that Newton published his Principia, de Fontenelle is speculating about the possibility of extraterrestrial life. And the beautiful thing about the book is how it's structured. So it's a conversation between the philosopher himself and a marquise, a female protagonist, being essential to the narrative of this book, because, you know, in those days, the salons where people would discuss intellectual ideas, kind of like this, you know, were very much run by female nobility. So the marquise was the one that would be asking the questions to the philosopher about walking, you know, as they walked in the gardens of the castle at night. So it's a real lovely, lovely book. And at some point, she asks the philosopher, so what is philosophy? And by philosophy, he was really talking about natural philosophy, which we nowadays kind of call science, right? And this is the answer that I love. All philosophy is based on two things only: curiosity and poor eyesight. And I think that's just perfect, because we humans are very curious, right? We want to know. And yet, we are myopic. We can only see to a certain extent, right? And he captured that in a beautiful way. And then he continues this by saying, but the problem is that we want to know more than we can see. And I think that's why I think Reinhold Niebuhr, thank you, said that man is his own most vexing problem, right? I mean, this is the question we are trying to solve in a sense, right? So there you go. So we're stuck, right? And then, of course, much later comes Heisenberg, who has this conception of quantum mechanics in which it really is based on observations, and Carlo already talked about this in the first talk, right? In which he says this, that what we observe is not nature itself, but nature exposed to our method of questioning. And I think that's extremely important, because it humanizes science. It puts science on the eyes of, we are these creatures asking questions about the world in order to make sense of it. And in the process of making sense of it, we're making sense of who we are as well, right? And I think that's extremely important, because that's opposed to the notion that, I think he's following Bohr here, you know, the notion that there is an absolute answer out there, and our task as scientists to figure that answer out, right? And so, in terms of how we do this, how we build this worldview, so to speak, I would start here. You know, what is the material we as creatures is first experience. Now, I was having lunch, no, we were walking together, Jay and Jenan, after lunch, and I edited, because I realized that I wanted to make sure that we have to understand that when we talk about the primacy of experience, which is something that Evan was talking about, and I'm sure Adam is going to talk about tomorrow, I'm really sorry I won't be here, is we don't mean experience as something in the world, because experience only makes sense as embodied. Right? So we talk about embodied experience. And that's where everything comes from. And does any of you know this painting? So it's a picture by Rembrandt, and the title, which what I love, is you've seen Rembrandt, his self-portraits, right? He's always like incredibly sad and depressed. This is one self-portrait where the title is Self-Portrait in the Image of Laughing Democritus, because Democritus was a laughing philosopher, right? And why was he? Because he, through his narrative of atoms and the void, he tried to dispel all the supernaturalism that was rampant at the time. And he was confident enough that he figured things out, but he also said this, and this is one of his fragments: in reality, we know nothing, for truth is in the depths. And that kind of starts to resonate a little bit with some ideas of Buddhism, especially the notion of the ephemeral nature of Dharma, at least according to Nagarjuna, right? So, and then to illustrate that science is an ongoing process of creating a narrative to describe what we see of the world, here is a brief history of nothing. So let's start with them. I won't go before them because then it will be a very long, brief history. But so they start with atoms and the void. So they say there is stuff made of little bits that don't break up, and they move in emptiness. Then Aristotle shoots that down and said, no, there is no emptiness, there is ether that fills out all of space. And then Descartes comes and says, yep, I also like this idea of the plenum, and now I have vortices, right? And then Newton comes, and if you read the Principia, which is a really hard read, but at least parts of it, you see that one of the main goals of, well, apart from others, but one of the main goals of Newton was to destroy Descartes. And he does it by saying that, no, there is emptiness. Because if there were stuff in the universe, like matter, friction would let the moon fall onto the earth, and he calculates that, and he then shows that it's, again, the void. And he was an atomist. So back to the atoms and the voids with Newton, right? And then I'm going to skip Young and light, but then, of course, the propagation of light asks for another kind of stuff to be in there. So you have the luminiferous ether to fill out all of space. So you have this propagating medium for light. So it's not empty again, right? And then Einstein writes his equations in 1915. In 1917, he comes up with this model of the geometry of the universe as a whole, which is absolutely spectacular feat of intellectual brilliance, right? You, on your desk, you calculate the universe. You solve an equation that tells you this is, for me, the shape of the universe. Beautiful. But then, when he looks at it with his original equations from 1915, he calculates, we love to do that. We have a system, we perturb it to see what happens to it. So he perturbs it, the system collapses, and then he's, damn. So what he does is, well, you know what? The mathematics of my equations allow me to put this extra term in there, which he does, which we now call the cosmological constant. And the role of the cosmological constant was precisely to kind of avoid this gravitational collapse. And he gets a static, spherically symmetric, very kind of Platonic notion of a static universe with beautiful symmetry, which is a wonderful thing, right? You want something beautiful, simple, symmetric. And so there is a cosmological constant. And then Hubble starts doing his stuff with the 100-inch Mount Wilson telescope, and he finds the expansion of the universe. And Einstein visits him in 1931, and, you know, okay, there's no cosmological constant. So, okay, it's empty again, you know, empty again. Wonderful. And then, of course, we have quantum fields, right? And quantum fields have this thing called vacuum fluctuations, in which there is no true emptiness anymore, because there is this zero-point energy that a lot of, well, let's see, you talked, Jessica, about the indeterminacy as, so there you go. There is something, indeterminate there, particles come up, they pop up into existence, they disappear, so the quantum vacuum is not empty anymore, so emptiness goes away. And to make things more complicated, in 1998, we have discovered that the universe is not just expanding, but is accelerating, and hence you have this thing that we're calling dark energy. I was having this conversation with Carlo right before the conference, and he thinks it's a cosmological constant, very possible. We do not know what it is, but it's there. Right? So why do I bring this, which I'm sure a lot of you know about, is because it's the elusive nature of truth in science. You know? And I think that is a very important point, right? And apart from that, so I said first, the material is experienced. Then what we as scientists do is we amplify this experience of reality. So we create these instruments, which I call reality amplifiers, which is exactly what they do, right? So Galileo 1609 points the telescope to the moon and says, hey, Aristotle, I'm really sorry, the moon is full of holes and mountains, and it has nothing to do with this perfect ethereal sphere at all. And Jupiter has moons, Venus has phases, the Milky Way is not like this gas thing, it's actually made of lots of dots, which are stars. So the picture of the universe, of reality that was held until then, crumbles down because of that single instrument. So instruments have the power of changing worldviews. And that is extremely important. And we need them in order to adapt ourselves to these new worlds that we discover. Same century, the microscope does the same with life. If you look at what people were thinking about life in the 1670s, it was completely different from what they were thinking about life 20 years later, because in a drop of water, there are all these little creatures that people couldn't see before. So all sorts of interesting questions appear because this new instrument amplified our view of the world, and so on and so forth. It is very important to consider 2 points here. The first one is that because of this, because of our dependence on instruments in order to make sense of the world, we also depend on the technology of our time to construct our worldviews. So the worldview of the 17th century and the 19th century and the 21st century, they have been changing because we can look at things in different ways, because we have these amplifiers that allow us to do such a thing, which is a great story, right? But we can never forget that tools also have a range of precision. They do not see everything. I have a picture here of this thing is, so this is the Atlas detector at CERN. There's a person here. I actually was there. I was shooting a documentary for Brazilian television right before they closed it. So I went into there. That's not me, but it is a magnificent structure, right? And the biggest machine we've ever made to measure the smallest things that we think exist. And even there, we can't see everything. That has a limit of precision. It has an energy threshold beyond which we cannot know what's going on. So when people say, what is the fundamental structure of matter? The question that Thales or somebody else, now we don't know. There was a paper that came out the other day from Oxford saying that, you know what, Thales was not the first Western philosopher. Apparently there's a whole discussion about this now. It doesn't matter, but he is the guy that has the credit of being the one that asked, what is this stuff of the world? We're asking the same question, and notions of finality, oh, it's quarks and leptons, can never be taken to be the final truth because we do not know. There are 4 fundamental forces in nature. Now there are 4 fundamental forces in nature. 150 years ago, there were only 2, right? How do we know if there won't be other forces in nature? So once in a while, we see a paper, the 5th force has been discovered. So I think this is an important point because it gives you a notion that even in physics, the fundamental structure of reality is an ephemeral dharma, so to speak. It's fluid, right? Okay, and I love this we finally, what do? Well, we measure this stuff and we create models. And I love the map and the territory idea. I love Borges' one-paragraph short story of the map makers, right? That basically it goes, I don't know how many, do you all know the story? So, all right, so Borges wrote this one-paragraph story, right, where he says, you know, there was a time in an imaginary place, etc., where the king asked the map makers to make a map of the land, of the kingdom. And they made it. It was not perfect enough, so he asked me to put more details, and put more details, and put more details. Eventually, they have a beautiful map of the land that was as big as the land itself. And that map, of course, is useless, because the purpose of a map is not to reproduce the territory, but is to synthesize information about the territory that can be useful for certain purposes, right? And that is exactly what science does. So our theories are maps of this territory that is only partially accessible to us because of the limitations we have with our instruments. And here's one map, the quantum map, right? So here it is. These are the only equations in this talk. So you have the wave function collapse in brief. I mean, he already put a lot of equations in, so I'm not feeling as bad as you. You started. No, you had some too, so what can we do? We love our maps, right? But the point is that in quantum physics, you know, you create, I don't have a pointer here, but you create a state to represent a physical system, which is a superposition of eigenstates with certain weights, right? And before you make the measurement, as Genan was always talking about, you don't know what to say, you can't even have knowledge anymore, right? It's a disgrace. But then eventually you make a measurement and the system so-called instantaneously collapses into a particular state with a certain eigenvalue. And I have a guy here in the audience that loves to bet, oh, where is this? That loves to bet on that. So he bets that it's going to be with a certain value, which is, you know, the absolute value of that particular constant in front of that state, okay? This is a measurement. It's a map. Is this reality? Clearly, it's a representation of reality, right? And I remember once Truman Dyson told me that he did not understand this whole conversation about the wave function because to him, the wave function was never devised to be a real thing. It was devised to be a representation of something that could organize data, you know. So, which is something that different people mention. So, the claim that the world is quantum, I would even qualify that and say, quantum is a map of the world that we can experience. You know, because when we say the world is quantum, we are giving a finality to quantum theory that perhaps it doesn't deserve. No scientific theory, I think, and here I am after 40 years being a scientist saying this, deserves that kind of claim, you know, to reality. We're just making maps, and some of them are incredibly good, obviously, but that doesn't mean that they are the world beyond us. So, and of course, this is something that people already talked about, and yes, quantum mechanics is weird. The conversation that we're having about interpretations is this wave function epistemic? You know, does it, in the Buddhist language, does it exist conventionally, or is it ontic? Does it exist inherently? You know, and one way I think about it is that really the wave function is a superposition of possibilities, you know, in the sense that I can bet on the outcome of a certain experiment. Now, Nagarjuna, whom I have to thank Jay and John, because honestly, all I know about Nagarjuna is from your stuff, so if I'm saying something stupid, it's your fault. Or maybe I'm so stupid that I can't even understand what you said, I don't know. But basically, he's saying that all phenomena is existing conventionally, right? And there's no essence to these phenomena, right? And the idea, I think Jay, actually, yeah, you mentioned in your book the notion of a table. What is a table, right? And then you go beyond. You have a footnote that says, well, a tree follows the same idea because where the boundaries of the tree, the branches fall. So the identity of something like that as permanent is very dangerous. And here I add my own, which is, what is the difference between the mountain and the sandy beach? Because, you know, this is the mountain and the sandy beach now, but the mountain will become a sandy beach in many millions of years. So what kind of identity is that, right? So that is what I mean about the identity of something in the world being ephemeral. And another example is the neutron. The beautiful neutron. The neutron is a kind of a mysterious thing, right? Because a neutron, as you know, part of the nucleus there with the protons of the atoms, right? So when the neutron is alone, not as part of, so a free neutron propagating in space, decays into a proton, an electron, and an electron antineutrino, doesn't matter what that means, in about 15 seconds. So if you ask me what is a neutron, it completely is contingent on where is this neutron? Is it part of a nucleus? Is it alone? So the identity of a neutron depends on the contingency of where it is and the system that it belongs to. And I think that is a very important. So you cannot really attach identity to things like that. You know, we like to say, and you know, that the electron is a point particle, right? So that's one thing. Oh, electron is a point particle. A proton is not, because it has structure, you know, quarks and gluons and stuff. But the electron is a point particle, and obviously a point particle that has mass, electric charge, and spin. And when you look into quantum field theory, it's not a point particle anymore because it has a cloud of fluctuations around it. So you say it's a dressed, normalized thing, right? So the idea of pointness doesn't really work anymore when you look at quantum field theory. So what is an electron depends on where you're asking the question, you know, which contingency or context you're asking that question. So the idea then is that we are perceiving this reality that we measure through tools, and the measurements or the information that we acquire from the measurements, right? They are updates to our experience of the real. You know, I didn't know something, a measurement comes, and I'm going to update what I know about the world from that particular measurement. Okay? And then you say, wow, I'm constructing a worldview with all this information. Does that mean that what I'm perceiving of reality through all these amazing machines is the true reality? Right? And no, you know, this is just perceived reality is just perceived reality, period. Okay? And I bring Whitehead here since he appears in our book that we're writing together. And that is an example of a fallacy of misplaced concreteness, to think that science actually tells you something fundamental about the nature of reality. And when we're telling, what we're doing is constructing a narrative where there is this flow of ideas that moves on in time about what reality is. If I ask, you know, a Portuguese conqueror that came to Brazil in 1500, Pedro Álvares Cabral, what was the universe? Right? He'll give you an Aristotelian answer as a man from the 1500. And of course, if you ask that to Galileo and Kepler, you have a different answer. If you ask that to someone of us now, we have a very different answer. Is the universe different? Of course not. But our narrative that we're constructing about the universe definitely is different. Right? And that's what we're trying to do all the time. We're trying to update our experience of the real through these measurements. Okay, now, what do we do with this worldview then? So here's where I'm going to maybe repeat a few points that I already made, you know, about the troubles with the typical blind spotty Western scientific thinking. So here's one. It starts, first of all, by taking the human out of the picture and reifying natural laws. So it's confusing the map and the territory. You know, that's one thing. Then, that being is more fundamental than becoming. And, you know, I'm not a philosopher, but I love pre-Socratic philosophy, and I know Carlo does too, right? And this conversation is really old, right, about being and becoming, right? And I imagine that you have things like this in your world, right? But the notion that what is essential is being, you know, from Parmenides, that influences Plato, that influences Steven Weinberg and all the string theorists, you know, the notion that there is a thing out there that we can uncover. And then you have people like Anaximander, that I love, like just like you. I didn't write a book about him, but I really love him. And Heraclitus, they say, no way. You know, it's really about flow and transformation. You know, there's no place to anchor stability when you have a world that is always in transformation. And I'm putting belief here on purpose, you know, this word, just to kind of annoy, you know, people that, so yeah, like, no, I'm a scientist, I'm an atheist, I don't believe in anything. Man, you believe in a lot of stuff to construct a worldview like this. So believe on the fundamental causation. I mean, that was what he did, right? Newton, you know, action at a distance. It happens instantaneously, Earth, Sun, right? And then when he was asked, what is gravity? You know, he says, I feign no hypothesis. I'm not going to guess. But he goes, whether it's something material or non-material, I'll leave it to the discretion of my readers. You know, and of course, he they says, I'm going to do the same thing, right? And we did PR. And afterwards, and then, of course, the same year, if I'm not mistaken, that the EPR paper comes out is when the poor Schrodinger's cat paper comes out too. I think it was 1935, both of them, right? And Schrodinger writes that paper. We killed a lot of cats in this conference, by the way. It's not clear. Yeah, that's true. So he tries to do the same thing, and he fails. And that was, to the end of his life, what I'll call his quantum samsara. He suffered because that destroyed the worldview. So the fight between Einstein and Bohr really was a fight between worldviews. It was a clash of what is the world like, right? And he tried really hard to shoot things down, but he couldn't. And that's his, sort of like his quantum samsara. Right? And finally, there is this belief on a final and true ontology, you know, the notion of theory of everything. I mean, that name is awful, right, for many, many reasons. And I'm a little guilty because my PhD thesis was on string theory, right? But then I grew up and I changed completely the way I looked at stuff. You know, because to believe that you can create a geometry, I mean, that's the ultimate Platonic dream, right? The blueprint of reality is a geometrical theory of nature that encompasses all forces, right? And Einstein, as you mentioned, I think it was when we were having lunch or dinner, like he spent 20 years of his life or more trying to do this with gravity and electromagnetism. He wanted to geometrize nature because he was so successful in gravity. And it is beautiful, but beauty is not always truth. Sorry, John Keats, you know, it just isn't. And that's where this notion of the view from nowhere has percolated through physics. All right. And finally, the belief that being is unoriginated. So Stephen Hawking and Jim Hartle, somebody mentioned Jim Hartle too recently in the conference. Oh, it was you, with the agents, right. So I was a postdoc in Santa Barbara, so I know Jim really well. And so this quantum cosmology idea of starting with a timeless universe, right, this Euclidean space-time that has no flow of time, is the ultimate notion that you can have being which is unoriginated, right? I mean, you can create something out of, quote, nothing, right? And to me, it's just another example out of hundreds of examples in the history of science of how we cannot make sense of the first cause. You know, because if you look at this problem, first of all, if you look at the formalism of quantum cosmology, there are serious conceptual problems with it. The Hamiltonian is not bounded from below. We don't really know where things are going. And still, this has been sold as the problem for the origin of the universe, the solution using quantum cosmology, when it really isn't, because it also makes use of a whole conceptual structure of quantum physics, relativity, wave function, states, energy conservation, that of course comes from where? Right? So I think the problem of the first cause is, to me, even more vexing, or perhaps it's not because we are the ones thinking about it, but it is certainly one of the most difficult questions you can ask. Right? And Leibniz already knew that. Right? How come there is something rather than nothing? Is there anything else on my list? Yeah, so then comes Nagarjuna, right? And he says, well, so only dharmas are ultimately real. So they go, right? Only dharmas are ultimately real. Only dharmas have intrinsic natures. Good. We're getting, so that line of Buddhism seems to be going that way. But his dharmas are not atomistic in the sense of the Greek atomism, because in the Greek atomism, atoms were eternal. In his case, they were flowy. They were subject to origination and cessation, as far as I understood your explanation, as opposed to the Abhidharma thinkers. They had a more settled, so to speak, way of thinking about the structure of reality. So they are impermanent, they have no enduring essence, and the same with ultimate reality. So the idea of capturing the essence of ultimate reality is a futile idea, according to Dr. Nagarjuna there. And the conclusion then is that there is an irreducible fluidity to all that exists, including the eye that sees the world, the observer. So, to make it a little more existential, I say this: we are just ephemeral agglomerates of stardust, aching for permanence. That is our problem, folks. How we're going to deal with it, it depends. But this is really the issue. Because I was just talking to Jessica at break there, and we were talking about death. And to me particularly, and I would love to hear what you guys say about this, the question is not dying. The question is not living. That is the problem, because it's the experience of being alive that is precious. Once you die, who cares? So it's about knowing that you're not going to be giving more talks at conferences, having a beer with Jay. That to me is what matters in the end. Right? So I think that's a very important point. And finally, I want to bring one way in which I try to make sense of all this, which is a metaphor called the island of knowledge, that is the following. Genan's collection of knowledge of obtained or non-obtainable, fits in an island. And as we know more about the world, this island grows. Right? Now, every good island is surrounded by an ocean, which is the ocean of the unknown, what we do not know about the world yet. However, the paradox of knowledge is that as the island grows, the boundary between the known and the unknown also grows, which means you know less because you have new questions to ask about the world you're studying. Right? So the whole point here is that there is no end to the quest. And that is, I think, in a sense, that's capturing a little bit this ephemeral nature of human knowledge about stuff. Now, when I was writing this book, diligently, I did a little bibliography search, and I realized that some other guys have thought of in different ways about the same idea. So there's a list. So Nietzsche, Viktor Weizsäcker, John Wheeler, who actually does mention an island of knowledge. I was devastated when I saw that. And then Sir William Dampier as well, right? But the point here is this notion that there is this unknown, and then of course there are unknowables. There are and I'm talking within, not just within the tradition of what is the ultimate nature of reality, there are fundamental, simple scientific questions you can ask that do not have an answer. I'll give you two examples. One example is, what is the origin of life on Earth? Right? Can we know that for a fact? Well, if you go to a laboratory, and I'll start talking to Greg about this. If you go to a laboratory and you synthesize life by putting together a bunch of organics, right? And it starts to form a cell structure and develops and reproduces. So it's living now because it's reproducing, interacting with the environment. That does not tell you that's how life emerged here on Earth. Because that's a story that has no memory. Because the way the planet evolved for the first 600 million years of its existence obliterated any information you could have had of stuff that gets imprinted in some sort of rocky substrate to tell us what was going on. So unless you can prove a theory in biochemistry, there is only one way to go from abiotic chemistry to biotic chemistry, which I don't think that's possible. You can answer that simple question, which is kind of disturbing. The other one is what's beyond the cosmic horizon. So, we live in a bubble of information. We are talking about the fish. We are the fish in the information bubble of how long the photons. We do not know what's happening beyond that, and we do not know, we cannot know what's happening. We speculate with reason that it's just more universe, because the universe is flat, approximately, and so, but we cannot know. So there are fundamental questions that we just don't know the answer to, which is a very important thing to know, and to respond to people that say that science will eventually have all the answers. This whole scientism, triumphalism, that I think is very dangerous, to be honest. So I have some thanks there for John and Jay because of your awesome text. And I just want to mention this. So the way I integrate Nagarjuna is by writing something like this, that the map of what we call reality is an ever-shifting mosaic of ideas. It's shifty, it's changing because we're learning more and more, right? And this map maker, this empty eye, is the eye that suffers most for his insistence on permanence. So if we let go of permanence, we let go of the first cause, we're going to spiral just like Democritus. That's my opinion of it. So last thing is, so Einstein went to the beach, Einstein on the beach, the Fiberglass Opera, and he was having a good time. I think it was the Jersey Shore. And he saw Nagarjuna floating in a blissful Buddhahood kind of cloud, right? He says, can I ask you a few questions about quantum physics? Right? So there they are. So Einstein's there on the beach with his very sexy legs. And Nagarjuna is there too. And so Einstein is saying, what am I doing wrong with quantum physics? So this is what Nagarjuna says to Einstein. He said, Albert, your quantum samsara can be your pathway to nirvana. Thanks all of you.
And I think, among other things, you remind us a number of fantastic things about the way to think about science. And you demolish a certain idea about science, which is wrong and realistic as a science of our provider of truth and definite picture of reality, and a long list of. And I think this is enormously important because often when people refer from the outside to the scientific view of the world, they forget that this is messy science, and not.
Exactly.
And not. Having said so, let me say a word in defense, in partial defense of science, which is the following: this total mess is sort of the best we have.
Absolutely, no question.
And let me say something against philosophy and the science, not against the philosopher here, but against a number of philosophers. But there's a lot of philosophy that says science is arrogant to pretend to know all that. And science is wrong. And we know better. And this reminds me, come from it's a quote from Langley, but these two old people on the bench, very two old men, and he says, "Oh no, this physicists don't talk about it. What do they know? I don't know. We know it." Exactly. Yeah. So I think this mess is the mess in which we live. Yeah. And exactly. And that's the best we can do. Maybe it's crazy. That's my perception. And beautiful. Absolutely.
Give a talk. Sort of along the same lines, I want to give a defense. I want to say that the list of things you gave for the problems of Western science, I want to put back at you and wonder whether we can think of these are the triumphs of it in a way. If you think of it more in terms of a kind of aspirational goal. Mm. The historian of physics, Roberto Turretti, he talks about when Einstein wrote down the field equation, and he was surprising. He said, "lunge for totality," and so it's like a fine balance, I think. So on the one hand, you can see dangers of the lunge for totality, but on the other hand, I'm sure you would agree you wouldn't want like a counterpart of you to go back, with the apocryphal story of Newton looking at the apple and then looking at the celestial sphere and then thinking. You wouldn't want the counterpart of you saying, no, Newton, don't go lunging for totality. Don't try to use your earthly physics to explain the solar system. That would be, reaching too far. Mm. And so it's sort of, as long as you don't think you're done, you're right. Having this as the kind of goal in front of you, the carrot, has been very productive.
Absolutely. And that's why, let me see if I can do this. Oh, it works. That's why I have that picture, and the island is growing. So obviously, that's what I've been doing for 40 years, writing all these papers, trying to make incremental growth. But what worries me of course, we have to aim at things, but with the understanding that there are limitations to what we're doing, and not dive into the dream as if it were true, but only as if it's a dream, And there is a difference. It is a kind of funny predicament because if you don't think it was attainable, you might not try. Well, I don't know. I felt the same way the first time I ran 100 kilometers. I never thought I could do it. It was my dream to do it and work really hard, and then you do it. But I know I can't do 100 miles, so I won't try. Because that's not realistic, and I think what happens is the hubris takes over. And that's why I started this talk with that quote from Einstein about, we can comprehend things only imperfectly and should feel as with humility, not because we should stop, absolutely not. That's all we have to make sense of reality. But we should have the humility to understand that the world is much vaster than our grasp of it. That's all. But that doesn't mean we should give up. You want to continue working on unification and string theory? Absolutely, because all their work in string theory was very useful to understand black holes, for example. Right? So and even quark physics nowadays, confinement and stuff like that. So there are payoffs, right? There are definitely payoffs. Oh, I wanted to make one more comment, which I think is interesting. I forgot, which is so Nagarjuna. I don't know if there is a precise date, but you guys talk about 100, 150 CE. That's when Ptolemy was doing his epicycle models in Alexandria about the same time, which of course they don't exist, but they have wonderful descriptions to within one full moon of precision of the motions of the planets, and that's just amazing. So we should never stop, obviously, God forbid. No, I'm the evangelist of science, but on the other hand, I also want people to be a little more careful than just go crazy with ideas that honestly are pretty empty, and there are quite a few of them out there.
I disagree with this, but it's along the same lines. Maybe just being articulate about the good, saying out loud what one of the good teachings of this sort of practice where you're super ambitious and you make a bold conjecture and you make it precise. I think philosophy is lacking. You make it regimented and precise enough that it gets a real confrontation with
Yeah.
Every failure is an increase in knowledge for exactly that reason. So every failure, in a way, is a triumph of we learned something different. We learned one of the things that's not right, and that gives you sort of pointers. And I think sort of that, again, echoing what Craig said, that history of failures is a kind of triumph.
Of course.
Sort of articulating something clearly and precisely enough that it can be confronted with that.
And that's what makes science special. Absolutely. I mean, and you can even go more to the point, like what Gell-Mann did with quarks, that he guessed the existence of the quarks by looking at the symmetries of the strong interactions. And then they went and they measured it, and it was right where he expected it to be. That's just mind-blowing spectacular, right? But then, if you go from, and that is just the power of how you can apply mathematics and symmetry to understand things, to see almost in a prophetic way what we have not seen before, right? And there is this beautiful kind of give and take between experiments and theory, right? It's just when you go way beyond, and the danger is that what do we know now? Okay, we know particle physics at about 10,000 times more energy than the mass of a proton, about 10,000 GeV. So, okay, but we are making models of the universe, and I'm as guilty as charged, where I'm extrapolating 12 orders of magnitude by what I know from the energy scale to create models of the universe way beyond anything that we have tested. And we do that because if we don't do it, you got to find. But to make an affirmation that this is what was going on when the universe was 10 to minus 35 seconds old, that's what bothers me. That's why I like to go back to the maps, and that's what I mean. Science is tentative until empirically, validated in one way or another.
Kind of theme, but a lot of what you were saying is something that, as a metaphysician, I hear a lot. So there's various arguments that we metaphysicians look at you. What results have you come to agree upon? None. Your methodology is in incredible disarray. People disagree about foundational principles. Can there be necessary connections between distinct existences or not, and so on. These generate entire new, different frameworks that people wrangle over for their entire careers and beyond. But I think that a lot of the skepticism that gets directed towards metaphysics would apply also to a kind of skepticism about the doing of science. And this is really, I don't think I'm saying anything that's pushing back against your counsel that we should be humble. I think that's 100% correct, and also for philosophy as well. Our results are provisional. However, I don't think the provisional nature of our results thus far, the provisional methodology in particular that generates provisional results in turn, that's necessarily problematic or indicative of any in principle problems with our respective enterprises. And I'd also suggest that this is a separate point, but the idea that there's, the ultimate truth is that there is no ultimate truth and so on. I would say that is a premature assessment for both the case of metaphysics and philosophy, notwithstanding Sideritz's expression of a certain Buddhist way of thinking about things. And here I'll just say a couple of things about why, we might not necessarily need to be skeptical of these. Basic point is these are early days. We're kind of toddlers, in my view, from the perspective of intellectual history. We haven't been doing this very long. Even throwing in, let's say, 10,000 years ago, where there were people doing something recognizably like theorizing about cosmological or soteriological issues. That's nothing really in the scheme of things. We are, it seems to me, every generation becoming more articulate about our methodology. We're learning new things, some of them empirical, some of them broadly epistemological, right? With respect to, fruitfulness, on parsimony, etc. Things that theoretical desiderata that may or may not eventuate in something that's empirically testable, but still we can have overall, we can see how theories do that conform to those desiderata. Do they do better or worse, and so on. So I guess I would just want to say I'm kind of optimistic at the end of the day, that at least in the sense that for all we presently can say, we can explain the lack of convergence. We can explain the lack of, the fact that there has been, progressing falsification of sort of scientific theories and also of philosophical theories. That's just to be expected. Philosophy is hard. Science is hard. Enlightenment is harder. It's just, there's a lot to try to figure out. The data is all-encompassing. Our methodology is unfixed at this point. So anyway, I guess I would just throw that out there. And just by way of saying, too, that I feel your pain.
Yeah, but it's a good pain. It's a pain that takes you up to nirvana. That's the problem. But that's perfectly fine. John?
Just want to go over maybe this will be the last question. I don't know, but so try to give you a little bit of a softball in some ways. Going back to the map metaphor, which I think is a very useful one. What you mentioned, which is a key feature of the sort of map making from a Buddhist standpoint, at least the kind of Buddhist theory I'll be talking about tomorrow, is that maps have a purpose. And a map that would say, for understanding the sewer pipes here on campus might not enable us to walk to the alumni house, right? And vice versa. So I'm just wondering whether the map and the tools being used to make the map of quantum physics as a practice now, within a community of practice, whether there's anything that's kind of intrinsically blind spotty about that map or the practices for creating that map. Do we need to kind of backtrack in some fashion?
Well. So that's so in a sense you're asking me to take sides on the interpretation issue, and I'm definitely on the epistemic side of things. So I do not see how you can have ontological reality for that particular map. So that's.
But also part of it is like, what's the purpose? In a sense, what's quantum physics for?
That's what Bohr would say. It's to explain the data of experiments, and this works. And who cares if the wave function collapses or not? As long as I get my theory to explain what I'm measuring in the lab. And there is some validity to that, and that's why we still teach quantum mechanics like that to all physics students in the whole world. That's exactly how you do it, And there is a reason for that. But of course, when you start thinking more deeply about how does this subject-object relation occurs, and what is it that is going on when you make a measurement, and what does it mean for a wave function to collapse instantaneously, and what does it mean when you create a pair of photons and then you move them apart and you have this null locality that identifies each other through the other. Those are things that are very disturbing, and you can adopt a perspective like, I don't care as long as I can calculate. Is this shut up and calculate kind of approach, right? But people like this guy and that guy and say, come on, if I really want to get to the core of stuff, to understand something a little deeper about what's going on, I have to try harder. And I think that's the point. This is an attempt to try harder. Just like you should try harder to unify the four forces of nature, just don't say they're the only four forces of nature, and when I get to them, I'm going to have the final theory of everything. That's the hubris. I think that's the difference between the two things.